Hello everybody. Today I'm starting with core Java. So first I'll deal with the introduction part. Java is a high-level object-oriented programming language which is platform independent and is suitable for distributed applications. Now, what do you mean by object-oriented programming language? Why Java is object-oriented programming language? Java is object-oriented programming language because everything in Java is an object. And what do you mean by platform independent? Platform independent means if a language is suitable for executing its programs in any operating system, irrespective of its development, then it is said to be platform independent. And distributed application means Java is suitable for distributed applications like banking applications, etc. And Java is developed by Sun Microsystems in the year 1995, and James Gosling is known as the father of Java. Next, Java applications. Now we'll know what are these Java applications. Desktop applications such as Acrobat Reader, Media Player, Antivirus, etc. Second one is the web applications like irctc.co.in, etc. Third one is the enterprise applications like banking applications. Fourth one is the mobile applications. Fifth one is the embedded system. Sixth one is the smart card. Seventh is the robotics. Eighth is games, etc. So Java can be used in all these applications. Next, types of Java applications. What are the types of Java applications? First one is the standalone application. Standalone applications are also known as desktop applications or Windows-based applications. Now, I'll give an example. For example, if a system is there and if a user and a system is present, and if a user gives any input to the system, and the system in turn does some calculations and gives the output back to the user. This is known as single tier application, or it is also known as desktop application or Windows based application. And examples of standalone applications are media player, antivirus, etc. And what are the technologies used for creating the standalone applications? AWT and Swing are the Java technologies which are used for creating standalone applications. Next is the web application. For example, if you consider a user, a system, and a server, and for example, the user gives any input to the system will send the input back to the server, and the server performs any calculations and gives back the output to the system, and the system gives back to the user. Here, a server is present, and it is known as a two-tier application. So here an application that runs on the server side and creates a dynamic page is called a web application. And what are the technologies used for creating web applications? Currently, Servlet, JSP, Struts, Spring, Hibernate, JSF, etc. are used for creating web applications in Java. Next, enterprise applications. What are enterprise applications? An application that is distributed in nature, such as banking applications, is called as enterprise application, and it has advantages of high level security, and EJB is the technology used for creating enterprise application. And the fourth one is the mobile application. An application which is created for mobile devices is called a mobile application. Currently Android is used for creating mobile applications in Java. And my next topic is Java platforms or additions. There are three platforms or additions in Java. First one is Java Standard Edition, and it includes the Java programming APIs like java.lang, java.io, java.net, java.util, java.sql, java.math, etc. And it includes the technologies like OOP, string, regular expression, exceptions, inner classes, multi-threading, input-output stream, networking, AWT, Spring, reflection, collections, etc. The second one is the Java EE or Java Enterprise Edition. It is an enterprise platform which is used mainly to develop web applications and enterprise applications. It includes the technologies like servlets, JSP, web services, EJB, JPA, etc. And the third one is the Java ME or Java Micro Edition. It is a platform which is mainly used to develop mobile applications. Next, we'll see what are the features of Java. The features of Java are, first one is the simple. Every Java program can be written using simple English language, and these programs can be easily understandable by each and every developer, and also it is easy to develop. And Java is free from pointers. The disadvantages of pointers is there is no security for the data, and the burden on the developer is more, and the pointers are very difficult to handle. So that is the reason why Java is simple. Next is object oriented. Why Java is object oriented? Because everything in Java is an object. And what are the OOPS features? OOPS features are class, object, encapsulation, polymorphism, inheritance, and abstraction. Now, what is the difference between object and a class? For example, you want to construct a building. Then, in order to construct a building, first you need a blueprint or an architecture of the building. This blueprint or an architecture is an example for a class. And if you can, and after constructing the building is an example for an object. So object is a real world entity, whereas class is a virtual entity. That is, object can be seen, real world entity can be seen, whereas the class, which is a virtual entity, cannot be seen. So this is an example for object and a class. Next is encapsulation. What do you mean by encapsulation? Encapsulation means if a data members and methods are encapsulated into a single unit, are included in a, are combined into a single unit using a class, then it is known as encapsulation. And class is the best example for encapsulation. Next is polymorphism. The ability of an object to exist in its multiple forms is known as polymorphism. For example, there are different ways of communicating in this real world. That is, even the humans can communicate as well as the animals can also communicate in their own way. So the object which exists in the ability of an object to communicate in different ways is known as polymorphism. So next is the inheritance. Now, what do you mean by inheritance? Inheritance means the parent class, the child class can be the ability of one class inheriting the properties and methods from its parent class is known as inheritance. And that is, for example, if you consider a parent and a child, the child can inherit all its parents' properties. So this is an example for inheritance. And next is the abstraction. What do you mean by abstraction? Abstraction is nothing but hiding the unnecessary details from the user, is known as abstraction. And abstraction can be uh, easily explained with inheritance. And so this is about object oriented OOPS features. And next is portable. Why Java is portable? Java is a portable language. A language is said to be portable whenever those programs are executed in any operating system and in any processor, irrespective of its development. That is, portable means platform independent plus architecture neutral. Next is platform independent. What do you mean by platform independent? Java is platform independent language. Platform represents an operating system. A language is said to be platform independent whenever those programs executing in any operating system irrespective of its development. And a language is said to be platform dependent whenever those programs are executing in the same operating system where that uses where the user developed. Example of this platform dependent feature is C and C++. And example for the platform independency is Java. And every platform independent language should follow the below rules. The size of the data type should be same in every operating system. That is, example in Java, int data type occupies 4 bytes of memory in every operating system. Whereas C language, the int data type occupies 2 bytes of memory for 32-bit operating system and 4 bytes of memory for 64-bit operating system. And next is secured. Java is secured. Uh, excuse me. Java is secure. Why Java is secure? Java is secure because it is free from pointers. In general, for every program, developer should write another program or algorithm to provide security for the data. Whenever the number of programs are increasing, then the security programs or algorithms are also increased. And this leads to a burden on the developer. So to overcome this problem, Sun Microsystem developed predefined security programs for the at the time of designing of Java, so that the developer can use these programs to provide security while writing the programs. That is, Java also supports encryption and decryption techniques at very high level. And these encryption and decryption are the techniques mainly used to overcome the problem of hacking. And the next is robust. Why Java is robust? Robust means strong. Java is strong because for every programming language, errors are generated in two levels, that is compile time errors and runtime errors. Compile time errors are the errors generated at compile time, and these errors can be handled by any language very easily. Whereas runtime errors generated at the execution time of the program. That is, runtime errors are also known as logical errors or exceptions. And using structured oriented programming languages like C, it is very difficult to handle the runtime errors. And runtime errors can be handled using a special concept called exception handling. And exception handling is supported by Java. That means Java language is very efficient to handle runtime errors. So because of this reason, Java can be called as very strong or robust. And Java also has strong memory. Java is also having strong memory management. That is why Java is robust. Next one is architecture neutral. What do you mean by architecture neutral? Architecture neutral means the language can be executed on any processor irrespective of its development. That is, the language is processor independent. Java is architecture neutral means that its processor is it is processor independent. That is, the language is said to be architecture neutral whenever these programs are executed by any processor irrespective of its development. And next is interpreted. Java, what do you mean by interpreted? Okay, interpreted in the earlier versions of Java, the compilation process was very fast and interpretation process was a little bit slow. To overcome this problem, a special interpreter was used called JIT, that is just-in-time compiler. And JIT compiler will speed up the execution process of Java. So because of this reason, Java can be called as interpreted. And next is high performance. Why Java is called as high performance language? Because there is an inbuilt garbage collector for efficient memory management. This is one point. And the next reason is Java is free from pointers. That is, Java does not support explicit pointers, so that handling of programs are very easy and burden on the developer is very less. And Java is multi-threaded programming language. Because of executing multiple programs simultaneously, the time taken process can be reduced. And this is one reason. And the next reason is magic of bytecode, that is to increase its execution speed. That is why Java is of high performance. Next is multi-threaded. Uh, Now Java is, what do you mean by multi-threaded? Whenever any language supports multiple flow of controls, then it is known as multi-threaded programming language. And advantages of multi-threaded programming language are time taken process is very less, performance and efficiency is more, and problem occurred at one location is not reflected on the other area of the program. If you consider single-threaded programming language, the user is facing the problem of single-threaded programming language. That is, What are the disadvantages of single-threaded programming language? The time taken process will be more and the performance will be less or slow. Next, distributed. Why Java is distributed? In general, network-based applications are classified into three types: centralized applications, client-server architecture-based application, and distributed application. Now, what are centralized applications? Centralized applications are the applications where multiple clients are able to communicate with a single server. And in this scenario, only server system is having the components like hard disk, RAM, processor, OS, etc. But the client system is not having these individual components. Because of this reason, every request of client will be executed in only one server system so that the burden on the server is increased. So to overcome the above disadvantage, the client server architecture based applications are introduced. What are client server architecture based applications? These are the applications in which multiple clients are able to communicate with single server. But in this scenario, not only server system is having the individual components like HD, RAM, processor, operating system, etc., but even the client system is also containing these components so that the burden on the server can be reduced while processing the request. But the main disadvantage in this client-server architecture-based application is that multiple clients depends on only single server. Whenever any problem arises in server, then this will be reflected on every client system. So to overcome the above disadvantages, distributed applications are introduced. Distributed applications are introduced. Now, what are distributed applications? In this scenario, multiple clients can be able to communicate with multiple servers. That is, same application is distributed in multiple servers and all the servers are interconnected with a special network called internet, in which even one server is having some problem, then the client request will go to another server. That means the problem in one server is not reflected on other client systems. Next one is the dynamic. Why Java is dynamic? In general, for any program, the memory is allocated in two different ways. One is static memory or compile time memory, and second one is the dynamic memory or runtime memory. Now, what is static memory? Whenever memory is allocated at the time of compilation, then it is known as static memory or compile time memory. The major disadvantage in static memory is wastage of memory space, and this problem can be overcome using the dynamic memory. Now, what is dynamic memory? Whenever memory is allocated for the data at runtime or execution time of the program, such memory is known as dynamic memory or runtime memory. The major advantage with dynamic memory is no wastage of memory space. So Java supports only dynamic memory allocations. That means there is no chance of wastage of memory space. Because of the above reason, we can say that Java is dynamic. So I will conclude up to this point and I will continue in the next video. So thank you everybody. Hello everybody. Today I'm going to start core Java. First, I'm going to discuss about the introduction. This is the index in core Java. I'll deal with the introduction, OOPS concepts, strings, arrays, packages, exceptions, IO streams, multi-threading, wrapper classes, inner classes, collections, AWT, and swings. So first we'll deal with the introduction. Java is a high-level object-oriented platform-independent programming language which is suitable for distributed applications. Now, what do you mean by platform independent? Platform independent means a language which can execute or which can execute in any operating system irrespective of its development is known as platform independent. And what do you mean by object oriented? Object oriented means everything in Java is an object. And Java was developed by Sun Microsystems in the year 1995. James Gosling is known as father of the Java. Now we'll see some applications of Java. Java is useful in desktop applications such as Acrobat Reader, antivirus, media player, etc. It is used in web applications such as irctc.co.in, etc. and enterprise applications such as banking applications. Fourth, the mobile applications. Fifth, the embedded systems. Sixth, smart card. Seventh, robotics. And eighth, the games, etc. Now we'll see what are the types of Java applications. Standalone applications. First one is the standalone applications. Standalone applications are also known as desktop applications or Windows-based applications. For example, if you consider a one-tier application where a user and the system is present, the user gives input to the system performs some operations with the data, and the it gives back the output to the user. This is an example of standalone or desktop application. Examples of standalone applications are media player, antivirus, etc. And what are the technologies used for standalone applications? AWT and Swing are used in Java for creating standalone applications. Second one is the web application. For example, if you consider a two-tier application where a user, system, and server is also present. First, the user gives the input data to the system. The system gives the data to the server, and the server performs some operations and gives the data back to the system. And the system in turn gives the data output to the user. So an application that runs on the server side and creates a dynamic page is called a web application. And what are the technologies used for web applications? Currently, the servlets, JSP, struts, Spring, Hibernate, JSF, etc. are the technologies which are used for web applications. Now, third one is the enterprise application. An application that is distributed in nature, such as banking applications, are called as enterprise applications. And it has the advantages of high level security. That is, they give security for the applications. Next, in Java, the technology which is used for creating enterprise applications is EJB. And the fourth and the last one is the mobile application. An application which is created for mobile devices is called a mobile application. And currently, Android is a technology which is used for creating mobile applications. Next one is the Java platforms. We have three types of Java platforms. The first one is the Java SE or the Java Standard Edition. It includes Java programming APIs like java.lang, java.io, java.net, java.util, java.sql, java.math, etc. It includes the technologies like OOPS, string, regular expression, exception, inner classes, multi-threading, IO stream, networking, AWT, Swing, reflection, collections, etc. And the second platform is Java EE or Java Enterprise Edition. It is an enterprise edition this enterprise edition is mainly used to develop web and enterprise applications, and the technologies which are used for this enterprise edition are the servlets, JSP, web services, EJB, JPA, etc. And the third and the last one is the Java ME or Java Micro Edition. It is mainly used to develop the mobile applications. Next, we'll see the features of Java. What is the first feature? The first feature of Java is simple. Java is simple. That is, every Java program can be written using simple English language, and these programs can be easily understandable by each and every developer very easily. And it is also easy to develop. And Java is free from pointers. So this is the reason why, what is the disadvantage of pointers? If we use pointers, there is no security for the data, and the burden on the developer is more, and it is very difficult to handle. So for these reasons, Java is said to be simple. Next is object oriented. Now, what do you mean by object oriented? Object oriented means everything in Java is an object. And what are the OOPS features we are having? Class, object, encapsulation, polymorphism, abstraction, and inheritance. What is the difference between class and an object? If you consider a construction of a building, before constructing a building, you need a blueprint or an architecture of a building. So this blueprint or an architecture is an example for a class, whereas the building which is constructed is an example for an object. That is, object is a real world entity which can be seen, whereas this class is a virtual entity which cannot be seen. This is the difference between object and the class. And next is encapsulation. What do you mean by encapsulation? The the combination of data and the methods into a single unit, that is holding the data and methods into a single unit like class, is known as encapsulation. And class is the best example for encapsulation. And the next one is polymorphism. What is polymorphism? The ability of an object to exist in multiple forms is known as polymorphism. That is, for example, there are different ways to communicate in this real world. Example, humans communicate by talking to each other, as well as animals can also communicate in their own way. So, this is an example for polymorphism, that is the ability of an object to exist in multiple forms is polymorphism. And next is inheritance. What is inheritance? Uh, the one class acquiring the properties and methods into another class is known as inheritance. That is, if you consider a parent class and a child class, the child class can acquire all the properties and methods of its parent class. And next one is the abstraction. Abstraction is nothing but hiding unnecessary details from the user, is known as abstraction. And abstraction can be well defined using the access specifiers like private, protected, public, and default. And inheritance can be achieved using abstraction. And the next feature is portable. Java is a portable language. A language is said to be a portable whenever those programs are executed in any operating system and in any processor, irrespective of its development. That is, when Java is said to be portable, Java is said to be portable when it is platform independent as well as architecture neutral. And the next feature is secure. Why Java is secure? Java is secure because it is free from pointers. Uh, why? Because pointers is a burden on the programmer. So as Java is free from pointers, it can be said as a secure language. And every developer should write another program or algorithm to provide security for the data. So whenever number of programs are increasing, then the security programs or algorithms are also increasing. This leads to burden on the developer. So to overcome this problem, Sun Microsystem was developed predefined security programs at the time of designing of Java, so that the developer can use these programs to provide security while writing the programs. That is, Java supports encryption and decryption techniques at a very high level. And these encryption and decryption techniques are mainly used to overcome the problem of hacking. Next one is robust. Why robust means strong. Why Java is robust? In general, for every programming language, errors are generated in two levels. First one is the compile time errors. Compile time errors are the errors generated at compile time, and these errors can be handled by any language very easily. The second one is the runtime errors, and these are the errors generated during the execution time of the program. Runtime errors are also known as logical errors or exceptions. So using structured oriented programming languages like C, it is very difficult to handle these runtime errors. So runtime errors can be handled using a special concept called exception handling. And this exception handling is supported by Java. That means Java language is very efficient to handle the runtime errors. Because of this reason, Java can be called as very strong or robust. Next is architecture neutral. By Java, now what do you mean by architecture neutral? Actually, architecture neutral means that is Java is architecture neutral language. That means it is processor independent irrespective of its development. And a language is said to be architecture neutral whenever those programs are executed by any processor irrespective of its development. And the next feature is interpreter. Now, what do you mean by interpreter? Okay, like interpreter means in the earlier versions of Java, the compilation process is very fast and interpretation process was little bit slow. So to overcome this problem, a special interpreter is used called as JIT. That is just-in-time compiler. JIT compiler will speed up the execution process of the Java. So because of this reason, Java can be called as interpreter. Now high performance. Why Java is of high performance? Because Java is having an inbuilt garbage collector for efficient memory management. And second reason is Java is free from pointers. That is, Java does not support the explicit pointers, so that handling of programs are very easy and burden on the developer becomes less. And Java is a multi-threaded programming language. Because of executing multiple programs simultaneously, the time taken process can be reduced. And there is also a magic of bytecode, which is used to increase the execution speed. Next is the multi-threaded. Now, multi-threaded means, what do you mean by the flow of controls is known as threads. That is, whenever any language supports multiple flow of controls, then it is known as multi-threaded programming language. Now, the advantages of multi-threaded programming language are the time taken process is less, performance and efficiency will be more, and the problem occurred at one location is not reflected at the other area of the program. Whereas for a single threaded programming language, the time taken process will be more, the performance and efficiency will be less, and problem occurred at one location will be reflected at other area of the Java program. This is the advantage of multi-threaded programming language. And next is distributed. What is distributed? In general, network-based applications are classified into centralized applications, client-server architecture-based applications, and third is the distributed applications. Now, what do you mean by centralized application? Centralized application means multiple clients can be able to communicate with a single server. And in this scenario, only the server system is having the components like hard disk, operating system, and RAM, processor, etc. But the client system is not having these individual components. And because of this reason, every request of client will be executed in only the server system, so that burden on the server will be increased. So to overcome this disadvantage, the client-server architecture-based applications are introduced. Now, what are these client-server architecture-based applications? Here, multiple clients can be able to communicate with single server. But in this scenario, not only server system is having the components like hard disk, RAM, processor, and operating system, but also The client system is also having these components so that the burden on the server can be reduced while processing the request. So the main disadvantage in client-server architecture-based systems is the multiple clients depends on the single server system. So whenever a problem arises in the server system, it will be reflected on the each and every client system. So to overcome the above disadvantage, distributed applications are introduced. Now, in the case of distributed applications, the multiple clients can be able to communicate with multiple servers, but some application is distributed, same application is distributed in multiple servers, and all the servers are interconnected with a special network called internet. So what happens here, even one server is having some problem, the client request will go to another server. That means problem in one server is not reflected on the client systems. So that is why Java is said to be distributed, dynamic. Now, what do you mean by dynamic? In general, for any programming language, the memory is allocated in two different ways. One is the static memory or compile time memory, and second one is the dynamic memory or runtime memory. So what is static memory? Whenever a memory is allocated at the time of compilation time, it is known as static memory or compile time memory. The major disadvantage in static memory is wastage of memory space. And, this problem can be overcome using dynamic memory. And whenever memory is allocated for the data during runtime or execution time, then it is known as dynamic memory or runtime memory. And the major advantage with dynamic memory is no wastage. There is no wastage of memory space. So Java supports only dynamic memory allocations. That means there is no chance of wastage of memory space in Java. Because of this reason, we can say that Java is dynamic. So these are the features of Java. Thank you, everybody, and I'll continue in the next video. Thank you. Okay, this is my hello everybody. This is my second video of introduction to Java. Now I am going to cover the topic of C++ versus Java. Now, what is C++? C++ is a platform dependent. We already discussed that platform dependent means a language that can be executed on any operating system irrespective of its language that can be executed on only single operating system like Windows irrespective of its development is said to be platform dependent. So C++ is said to be platform dependent, and C++ is mainly used for system programming. And C++ supports the goto statement. It can support multiple inheritance. It can support operator overloading, and C++ also supports pointers. That is, you can write pointer program in C++. C++ uses compiler only, and C++ can support both call by value and call by reference. C++ also supports structures and unions. C++ does not have a built-in support for threads. Whereas if you consider Java, Java is platform independent. That is a language which can be executed on any operating system irrespective of its development is said to be platform independent. And Java is mainly used for application programming. It is widely used in Windows, web-based and enterprise and mobile applications. And Java does not support goto statement. Java does not support the multiple inheritance through class, whereas this multiple inheritance can be achieved through interfaces in Java. Java does not support operator overloading. Java does not support pointers. Java can use both compiler and interpreter. Java also supports call by value only. There is no call by reference in Java. Java does not support structures and unions. And Java has built-in thread support. So these are the differences between C++ and Java. Next, before going to execute the Hello World program, I'll show you how to, you need to download the Eclipse tool. So before executing the Java programs, you need to download the Eclipse tool. Go to Google and type it as Eclipse download. Then you select the link and you download the Eclipse and then install it. After downloading and installing the Eclipse, how to write the Hello World program. First Hello World program. The first Hello World program can be written, that is the following steps are to be taken. First you need to install the, after installing the Eclipse tool, you need to install the JDK, and if you don't have installed it, you download the JDK as well as JRE and install it. You need to install both JDK and JRE. Then set the path for the, then set the path of the JDK bin directory and also JRE bin directory. Then create the Java program, compile and run the Java program. Now I will show you how to set the path for JDK and JRE. First you go to My Computer Properties, Advanced tab, Environment Variables, then New tab of User Variable, then write path in the variable name, write path of the bin folder in the variable value. That is, this is the window. You go to My Computer Properties, then System and Advanced System Settings. In that, go to Environment Variables. In that environmental variables, if you click the environmental variables, you will see here user variables and also system variables. You can select the user variables. You click on New and then go to Path. Then write the variable name as path and variable value as the path of the JDK bin directory. That is, this is the path of the your JDK bin directory where you have installed the JDK. This is going to be your path. Copy the address and paste it into the value, variable value. In similar way, you can also copy the path of the JRE bin directory and then click on the OK button. So this is how you are going to set the, this is how you are going to set the JDK path of the JDK bin directory and JRE bin directory. Then create the Java program, compile and run the Java program. Now I will show you how to run the Java, first Hello World Java program. So first you need to go to Eclipse. So this is your Eclipse IDE, which I have already installed, downloaded and installed. So it is taking some time to open Eclipse. So this is my Eclipse IDE launcher. So you can change the workspace also if you want. I'm selecting it as the documents folder. I'm selecting the documents and then core Java. Then I'm launching the Eclipse. So it is taking some time to launch the Eclipse IDE. So we'll wait for some time. So this is my Eclipse IDE actually. So now I can select first what I need to do. I should go to the file, new. In order to run the Hello World Java program, first you go to file, new, and then select the project. Okay, in the project you select the Java project and say it as next. Then give the project name. I'm giving the project name as Hello World. Uh, Here I'm setting the Java SC standard edition is Java SC. Okay, no, you don't make any changes here, and then just say next. You don't make any changes, just say next time, finish. Then say finish. So this is how your Java project will be created. Then go into source, right click on the source, then go to new package. I'm creating one package here, com.core Java, com.core Java. So in this package, now I can write the Java files. So I should select, now click on the right click on the package, go to new and select the class. So now give the name of the class. My class is Hello World. Don't select anything here. Select only public static void main. And then say finish. So the first line is the package. Package is included here. Package com.core Java. The second line is public class Hello World. And the third line is the public static void main string arguments. Now here I am going to print it as system.out.println. I'm going to type it as system.out.println hello world. I keep a semicolon here. Then the Java strings won't accept single quotes, so you need to save it in double quotes. Now save the program. Here save button is there. Save the program. And how do you run this application? Just right click on the main project, just right click on the class and say run as Java application. So you should just say it as run as Java application. So your output will be displayed on the console. So this is how you will execute and run the Hello World program. Okay. Now what are the parameters used in this first Java program? Here we have seen a class keyword. This class keyword is just used to declare a class in Java. Now what is a public keyword? Public keyword is an access modifier which means that it is visible to all. If you use a public keyword, it is visible to all, everybody. Now next is the static. Static is a keyword, and if we declare any method as static, it becomes a static method. And the advantage of static method is that there is no need to create an object to invoke the static method. That is, this main method is executed by JVM. So this JVM does not require to create an object to invoke the main method. It also saves memory. Next is void. Void is the return type of the method. Void means that it does not return any value. Then main represents the starting point of the program. Then string args is used for command line argument. And system.out.println is used to print the statement. Here system is a class. Out is an object of the printstream class, and println is the method of printstream class. So how many ways we can write a Java program? By changing the sequence modifiers or access specifiers. By changing the access specifiers, we can write a Java program by changing the access specifiers also, but method prototype should not be changed in Java. What is method prototype? This void main string arguments is known as method prototype. This should not be changed in Java. And the subscript notation in Java array can be used like this. The string args can be used like this. It can be used before, after the variable, or before the variable, or after the variable also. And you can also provide where arg support to the main method by passing 3 ellipses, that is 3 dots here. These are the 3 methods, the 3 ways you can write a Java program. And these are the valid Java main method signatures. So how many are there? Eight ways are there. Eight types are there. So these are the 8 ways where Java main method signature is valid. Okay. Okay. So I'll conclude here, and I will continue in the next video. Thank you. Hello everybody. This is my third video. Now I'm going to discuss about JVM, JRE, and JDK. What is JVM? JVM is a Java virtual machine. It is an abstract machine, and it is called a virtual machine because it does not physically exist. JVM does not physically exist. And JVM is a specification that provides a runtime environment in which where Java bytecode can be executed. And it can also run those programs which are written in other programming languages and compiled to Java bytecode. And this JVM, JRE, and JDK are platform dependent because the configuration of OS is different from each other, whereas Java is platform independent. Now, what is JRE? JRE is an acronym for Java Runtime Environment. And this Java Runtime Environment is a set of software tools which are used for developing the Java applications. It is used to provide the runtime environment. And this JRE is the implementation of JVM. This JRE physically exists. It can be seen. And it contains a set of libraries plus other files that JVM uses at runtime. And JDK is an acronym for Java Development Kit. The Java Development Kit is a software development environment which is used to develop the Java applications. It also physically exists, that is JDK can be seen, and it contains JRE plus the development tools. Now I will show you the architecture of this JDK, JRE and JVM. I'll show you how the architecture of JDK, JRE and JVM. So this is the architecture of JDK, JRE and JVM. So inside JDK, we have JRE plus other development tools like Java C, Java, etc. And inside JRE, we have JVM and set of libraries like runtime.jar file and other files. So this is the architecture of JDK, JRE and JVM. So the next topic is the types of variables which are used in Java. We have three types of variables which are used in Java. Local variable, first is the local variable, second is the instance variable, third is the static variable. Now, what is a local variable? A variable declared inside the method of the body, inside the body of a method is called a local variable, and you can use this local variable only within the body of the method, inside the method. And local variable cannot be defined with a static keyword. And what is an instance variable? A variable which is declared inside the class but not within the body of the method is called instance variable. And this instance variable also cannot be static. And next is the static variable. A variable which is declared as static is called static variable and it cannot be local. And this memory allocation for static variable happens only once. That is when the class is loaded into the memory. And what are the data types in Java? Java has primitive data types. Java primitive data types are Boolean data type, byte data type, character data type, short data type, int data type, long data type, float, and double data type. Now, what are the operators in Java? Operators is a symbol which is used to perform the operations. And there are many types of operators in Java, like unary operator. Unary operator is operated on a single operand, and binary operator is operated on a two operands. If an operator is operated on two operands, then it is said to be binary operator. And if an operator is operated on three operands, then it is said to be ternary operator. And the next one is the arithmetic operator. Arithmetic operations are nothing but these are used to perform simple mathematical or arithmetic operations like addition, subtraction, multiplication, division, modulus, etc. Next is the shift relational operators. Relational operators are just used to check the conditions like lesser than equal to, greater than equal to, double equal to, not equal to, etc. Next one is the logical operators. Logical operators are used to combine more than one condition, like double ampersand, double or not. These are all our logical operators. And next one is the assignment operators. Assignment operators are used to assign a value to a variable. They are just used to assign a value to a variable. And there are many types of assignment operators like plus equal to, minus equal to, star equal to, div equal to, mod equal to. These are all assignment operators. And next one is the bitwise operators. And what are bitwise operators? Bitwise operators are used to perform operations on binary values like single ampersand, single or, XOR, and right shift, left shift, etc. Next one is a lot. Next one is okay. These are okay. So these are the operators in Java. And next topic is Java keywords. Java keywords are also known as reserved words. That is, they act as a key to a code. They are predefined words actually. Java keywords are the predefined words in Java, and they cannot be used as a variable or an object name. So what are the Java keywords we have? First is the abstract. Java abstract keyword is used to declare the abstract class. That is, what is an abstract class now? Abstract class can be used to provide implementation of an interface. Abstract class can contain both abstract as well as non-abstract methods. Next keyword is Boolean. Java Boolean keyword is used to declare a variable as a Boolean type. And this Boolean keyword can hold true and false values only. Next, break keyword. Java break keyword is used to break a loop or a switch statement. It breaks the current flow of the program with a specified condition. Next is Java byte keyword. Byte keyword is used to declare a variable that can hold 8-bit data values because 1 byte equal to 8 bit. Case. Java case keyword is used within the switch statement. Catch keyword. Java catch keyword is used to catch the exceptions generated by the try statements. And this catch keyword can be used only after the try block only. Character keyword. Java character keyword is used to declare a variable that can hold an unsigned 16-bit Unicode characters. Class keyword. Java class keyword is used to declare a class. Next, continue. Java continue keyword is used to continue the loop. Continue keyword is used to skip the current instruction, and it is used to continue the loop from the next instruction. It continues the current flow of the program and skips the remaining code at the specified condition. Next, Java default keyword. Now, what is the Java default keyword? Java default keyword is used to specify the default block of code in a switch statement. Um, Next, do keyword. Java do keyword is used in control statement to declare a loop. It can iterate part of the program. That is, what is a do while? A do while can iterate at least once, even before the condition is satisfied. Double keyword. Java double keyword is used to declare a variable that can hold 64-bit floating point numbers. Next is else. Java else keyword is used to indicate the alternate branch of an if statement. Enum keyword. Java enum keyword is used to define a fixed set of constants. And extend. Java extend keyword is used to indicate that a class is derived from another class or interface. Final keyword. Java final keyword is used to indicate that the variable, if a final is used before a variable, then that variable holds a constant value. It cannot be varied. Finally keyword. The Java finally keyword indicates the block of code in a try-catch structure. That is, finally block is always used after the try-catch block. And this finally block is always executed whether the exception is handled or not. Float keyword. Java float keyword is used to declare a variable that can hold 32-bit floating point number. Java for keyword is used to start a for loop. That is, it can execute a set of instructions repeatedly when some condition becomes true. Java next is the if keyword. Java if keyword tests the condition and it executes the if block if the condition is true. Next is the implements keyword. Java implements keyword is used to implement an interface. Import keyword. Java import keyword makes the classes and interfaces that is it makes the classes and interfaces available and accessible to the current class code. And instance of. Java instance of keyword is used to test whether the object is an instance of the specified class. Int keyword. Java int keyword is used to declare a variable that can hold 32-bit signed integer. Interface keyword. Java interface keyword is used to declare an interface. And it can have only abstract methods only. Interface can contain only abstract methods. Long keyword. Java long keyword is used to declare a variable that can hold a 64-bit integer. Native. Java native keyword is used to specify that a method is implemented in native using Java native interface. And what is a new keyword? Java new keyword is used to create the new objects. Null keyword. Java null keyword is used to indicate that uh, it does not refer to anything. Null means it does not refer to anything. Next, package. Java package keyword is used to declare the package that includes the classes and interfaces. Private. Java private keyword is an access modifier. Private keyword means the method or the variable can be accessed only within the class in which it is declared. Protected keyword. Java protected keyword is also an access modifier and it can be accessible within the package and outside the package through inheritance only. That is, it can be accessible within the package and subclasses of the other package. And public keyword. Java public keyword is an access modifier. It is used to indicate that an item can be accessible, class can be accessible anywhere. And the return keyword is the keyword used to return from a method when its execution is complete. And short keyword. Java short keyword is used to declare a variable that can hold a 16-bit integer. And static keyword is used to indicate that the variable or method is a class method. And the static is mainly used for memory management. That is to save the memory. Strict FP. Java strict FP is used to restrict the floating point calculations. Super keyword. Java super keyword is a reference variable that is used to refer to the parent class object. And switch. Java switch keyword contains a switch statement. And which executes the code based on the test value. Synchronized. Java synchronized keyword. Uh, why do you use synchronized actually? Synchronized if you use before a method, then Java creates a lock on that method. It means that when multiple methods are there and if you apply synchronize to one of the methods, then that particular method can only be executed. Then this keyword, Java this keyword can be used to refer the current object in a method or constructor. Throw keyword. Java throw keyword is used to explicitly throw an exception. And throws keyword, Java throws keyword is used to declare an exception. Transient. Java transient keyword is used in serialization. That is, if you use transient before a member, then it will not be serialized. Try keyword. Java try keyword is used to start a block of code that will be tested for exceptions. And try block must be followed by catch or finally block. Void keyword. Java void keyword is used to specify that the method does not have a return value. It does not return anything. Volatile keyword. Java volatile keyword is used to indicate that the variable may change asynchronously. While keyword. Java while keyword is used to start a while loop. And this loop iterates several times in the program. And if the number of iterations is not fixed, then it is recommended to use the hello everybody. Today in this video I'm going to explain about the OOPS features. Now what are these OOPS features? OOPS stands for Object Oriented Programming Structure. So what are the OOPS features we are having? We have class, object, encapsulation, polymorphism, abstraction, inheritance, association, aggregation, and composition. These are the OOPS features. Now first we'll see the difference between class and object. What is a class actually? Class is a container which is a collection of data members and methods used to provide security. That is, the class provides security to the data members and the methods. Whereas object is an instance of the class or class variable. And whenever class is defined, no memory is allocated for its data members. That is, without an object, no memory is allocated for the data members in the class. So whenever an object is created, sufficient memory space is allocated for the data members of the class. And only one definition should exist for a specific class in a program, whereas multiple objects can exist for a single class in a program. So this is the difference between class and the object. Next we'll see uh, the encapsulation. Now what do you mean by encapsulation? Encapsulation is one of the important features of OOPS, that is combining of data members and methods in a single unit is known as encapsulation. Or we can also define encapsulation as wrapping of data members and methods into a single unit is known as encapsulation. And any class which is having data members and methods is an example of encapsulation. So we can say that class is the best example for encapsulation. And next one is the abstraction. Now, what do you mean by abstraction? The process of creating user-defined data types is known as data abstraction. Actually, the main advantage of data abstraction is hiding of data. That is providing the security to the data. What is the main goal of abstraction? The main goal of abstraction is hiding of data, that is providing security for the data from unauthorized methods or classes. And in Java, class concept can be used to create the user-defined data types, which provides more security for the data from unauthorized classes and the from the unauthorized classes by placing within the container. That is, the class, what does it do? It provides more security for the data members and the methods by defining the user-defined by using user-defined data types. So in Java language, data abstraction can be achieved using the class concept. Next is the, so I will show you an example for abstraction. So okay, uh, first we'll study about this inheritance, then we go for abstraction. Now, what do you mean by inheritance? Actually, what is inheritance? So inheritance is nothing but it is the mechanism used to extend the properties of one class into another class, or it is the mechanism to create new class from the existing class. So, now what are the advantages of inheritance? Reuse. First advantage is reusability. That is, define once and use any number of times. What do you mean by reusability? You define the code once and use any number of times. Then second advantage is repetition of code or redundancy of the code is reduced. And the third advantage is no wastage of memory. That is, using inheritance, the wastage of memory is reduced. And in inheritance, mainly two types of classes are available. That is, any class that is given the properties to another class is known as super class or base class or parent class. And if any class is taking the properties from another class, then it is known as derived class or subclass or child class. And inheritance can be achieved in 5 different ways. That is, there are 5 different types of inheritance. First is the single or simple inheritance. Now, what do you mean by single or simple inheritance? Whenever the properties of only one class are inherited or extended into another class, then it is known as single or simple inheritance. I will show you the examples. That is how to do the programming for this inheritance. Second one is the multi-level inheritance. Now, what do you mean by multi-level inheritance? Extending the properties of multiple classes in a sequential or chain process is known as multi-level inheritance. And third one is the multiple inheritance. What do you mean by multiple inheritance? Extending the properties of multiple classes into a single class is known as multiple inheritance. So Java does not support multiple inheritance at the class level, but it can be achieved using interfaces. That is, Java does not support multiple inheritance at class level. Why Java does not support multiple inheritance at class level? Because of ambiguity. That is, whenever multiple classes are having same properties with the same name, then it leads to confusion to the processor at the time of inheriting all these classes into another single class. Next one is the hierarchical inheritance. That is, inheriting the properties of one class into multiple classes is known as hierarchical inheritance. And last one is the hybrid inheritance. That is, combination of the above any two inheritances is known as hybrid inheritance. Here in the inheritance, the Java inheritance can be achieved using extends keyword, and the derived class name can be any user defined name which takes the properties of the base class or the parent class. And extends is the keyword in Java used to achieve inheritance. And base class name can be any user defined name which gives properties to a derived class. And before existing of the derived class, the base class should be declared compulsorily. And after inheritance, all the properties of the base class, that is the data members or methods, are available in the context of the derived class. And whenever we don't want to access all the properties of the base class into derived class, then those should be preceded by a private keyword. And whenever an object is created for derived class, memory is allocated for the base class. Whenever an object is created for a derived class, then memory is allocated for the base class properties first, then later to the derived class properties. So inheritance can be restricted using the final keyword in Java. So now I will explain the this. Now I'll explain these types of inheritances in detail. First is the simple or single inheritance. So this is an example for simple or single inheritance. Now what do you mean by simple or single inheritance? Simple inheritance is nothing but whenever the properties of only one class are inherited or extended into another class, then it is known as simple or single inheritance. So here what is happening? I am taking a class animal, and inside the class animal I am defining a method void eat. Its return type is void, and I'm printing the system.out.println eating inside this function eat. Then I'm taking this animal is the parent class here, or the base class or super class. Then I am defining one more class, the child class or the derived class dog extends animal. Here dog is the child class or the derived class. And inside this derived class, I am defining one more method void bark, and I am printing system.out.println barking. Then I am taking a one more class single, where I am taking the public static void main method. Inside that, I am creating an object for the derived class. Dog D equal to new dog. Here dog is the derived class. D is the derived class object. Then I am accessing the both the methods, that is the method in the child class as well as method in the parent class using the derived class object. So this is known as single or simple inheritance. Now if you run this program, what do you get the output? You get the output is eating as well as barking. First barking, uh, okay, d dot bark means first the output is displayed as barking. Since this child class is in, since this parent class method is inherited into the child class, this method is also invoked. Next, eating is displayed here. This is the simple or single inheritance. Now, next is the multi-level inheritance. Now, what do you mean by multi-level inheritance? Extending the properties of multiple classes in a sequential or a chain process is known as multi-level inheritance. So, if you consider multi-level inheritance, here I am taking one class animal, and inside that I am taking one function eat. I am displaying as system.out.println eating. Then I am taking one more child class dog one. Class dog one extends the parent class animal one. Inside that I am defining the method bark. Then I am printing system.out.println barking. Then I am taking one more child class baby dog extends dog one. That is, this baby dog is the child class for the dog one, and this dog one is the child class for the parent class animal one. So this is a chain process. This whole thing is a chain process. And this weep method is inside the baby dog class. Inside that weep method, I am printing system.out.println weeping. Now I am taking a main method class here, and I am creating an object for the child class baby dog. D is the object for the baby dog, and I am calling all the three methods. That is d.weep, d.bark, and d.eat. Because this is in a chain process, all the three methods can be invoked using the baby dog object. So if you run this method, if you run this program, what do you get the output? You will get the output as d.weep means weeping, d.bark means barking, d.eat means you will get it as eating. So this is known as multi-level inheritance. Now next is the multiple inheritance. Actually, this multiple inheritance is not supported in Java. So we can go for hierarchical inheritance. Now what is hierarchical inheritance? Inheriting the properties of one class into multiple classes is known as hierarchical inheritance. If you consider hierarchical inheritance, class animal is the parent class. Inside that I am defining one function void it, one method void it, and I am printing system.out.println eating. I am taking one more class dog2 extends animal2, which is dog2 is the child class now. Inside that I am taking a method void bar system.out.println barking, and I am taking one more class cat2 extends animal2. So inside that I am defining one method void meow, and the output I am printing system.out.println meow. So now what is happening here? Only animal2 is the parent class here. For both dog2 and the cat2, animal2 is the parent class. And dog2 and cat2 are the child classes for this animal2. This is known as hierarchical inheritance. Now I am creating the object for the cat2. Cat2 c equal to new cat2 inside the main method. And I'm invoking the meow method using the cat2 object. And I can also invoke the eat method. I can invoke the eat method of the animal2, but I cannot invoke the bark method of dog2 because cat2 is not extending dog2. So if you invoke like that, you will get a compile time error. So now we'll see the output So meowing and eating is the output. This is hierarchical inheritance. Next is the hybrid inheritance is nothing but the combination of above any two inheritances is known as hybrid inheritance. Uh, Next we go for, so inheritance is completed. Now what is aggregation actually? Aggregation is nothing but if a class has an entity reference, then it is known as aggregation. Aggregation represents has a relationship, whereas inheritance represents is a relationship. Why aggregation represents has a relationship? Because one class is having the another class reference. That is, one class contains another class reference. So that is why it is known as aggregation. It is known as has a relationship. So now I will give you now this association and composition. I will explain you later. Now I'll show you the example for aggregation. See here, class operation. I'm taking inside that int square method, parameter int n. Then I'm returning n into n, and I'm ending the class. I'm taking one more class, class aggregation. Inside that, I am creating an object for this operation class. Inside aggregation class, I'm creating an object for the operation class, operation OP. I'm just creating a reference here. Operation OP is just I'm creating a reference for this operation class. Then double PI is 3.14, and I'm defining one method inside aggregation class, double area with parameter int radius. Then I'm creating an object for this operation class, OP equal to new operation. Then int r square is equal to OP dot square of radius. Then return pi into square. Uh, Now inside this aggregation class, I'm taking the main method now. I'm creating the object for aggregation. Aggregation C equal to new aggregation. Double result equal to C dot area of phi. Now here phi is radius. Phi is the radius now. So when you invoke the area method using the aggregation object, the control goes to the area method, and and here operation object is created, and the control again operation object invokes the square method. Control again goes to square method, and it returns the 5 into 5 is 25 is the result. Then it prints back the result. So if you run this program, so what do you get the result? You get the result as 78.5. That is 5 into 5 is the result. Sorry, 5 into 5 is returned here. Then here again pi into r square. It will return this method returns pi into r square, that is 3.14 into 25. That is printed as the result 78.5. Now next is polymorphism. Now what do you mean by polymorphism? Polymorphism is nothing but the ability of an object to exist in multiple forms is known as polymorphism. The ability of an object to exist in multiple forms is known as polymorphism. Now, this polymorphism is of two types: runtime polymorphism and polymorphism is nothing but existing of one method or constructor into multiple forms is known as polymorphism. It is classified into two types: static polymorphism and dynamic polymorphism. The main advantage of polymorphism is burden on the processor and the user is reduced at the time of execution. That is, instead of using multiple methods or constructors, single method or constructor can be used to perform the various operations. This is the advantage of polymorphism. Now, first we'll see what is static polymorphism. Whenever an object is binding with methods of class at the compilation time, then it is known as static polymorphism or early binding. And this can be achieved using overloading. It is overloading concept. The scope of overloading is within the same class. And dynamic polymorphism. What I mean by dynamic polymorphism, whenever an object is binding with the methods of the class at runtime or execution time, this is known as dynamic polymorphism or runtime polymorphism or late binding. This can be achieved using overriding. So this dynamic polymorphism can be achieved using overriding concept. That is, overriding, the scope of overriding is within the different class. And inheritance is mandatory to achieve the dynamic polymorphism. Now, what I mean by overloading, whenever any method, okay, this overloading concept I'll discuss later. So I'll conclude up to this. I will conclude up till here, and I will continue in the next video. Thank you. Hello everybody. Today I'm going to discuss about constructors. Constructor is a special member method. It is similar to a method in a class. Constructor is similar to a method in a class. And constructor is mainly used to initialize an object. And constructor name should be the class name, and that can be called automatic. Constructor name should be same name as the class name. And constructor can be called automatically whenever an object is created. Now, what are the rules to declare a constructor? Constructor name should be same name as the class name. And constructor should be declared within the class. And constructor should not have any return type. And no need to call a constructor explicitly. It will be called automatically whenever an object is created. Now, there are two types of constructors like no parameterized or default constructor and a parameterized constructor. Now first we'll see what is this no parameterized or default constructor. If any constructor does not contain any list of parameters within its signature, then it is known as no parameterized or default constructor. And this default constructor is again classified into system defined and user defined default constructor. Now what is this system defined default constructor? System defined default constructor is nothing but a whenever any class contains at least one user defined constructor, then system defined default does not be created, cannot be created and executed in JVM. So if any class contains at least one user defined constructor, then the system defined constructor need not be created and executed in JVM. So system defined default constructor does not have any logic. It is just a dummy function. And during definition, um, um, that is dummy function represents a method or a constructor having a signature but no body part. What is user defined default constructor? If any constructor does not contain variable declaration in its signature, and if it is defined by a user within a class, then it is known as user defined default constructor or no parameterized constructor. And this user defined default constructor is created automatically whenever an object is created without passing any values. Now next one is the parameterized constructor. Whenever any constructor is having list of parameters in its signature, then it is known as parameterized constructor. And they can be defined in two different ways, by declaring the list of variables and by declaring an object. And this parameterized constructor can be called automatically whenever an object is created by just passing the values and the arguments. So either user-defined default or parameterized constructor can be called any number of times by creating the separate objects for the same class. And constructor should be non-static. That is constructor, and the constructor scope of the constructor is within the class. That is, we cannot create or call a constructor of one class in another class. Now, what is this parameterized constructor? How can, by declaring the object as parameter? It is, instead of passing individual data members to a constructor, an object can be passed at the time of creation of another object. That is, the parameterized constructor, by declaring object as parameter, can be called by passing another object as a reference. Now I'll give some example. I'll show some examples of this uh, constructors. First is the default constructor. That is, first is, what are the two types of constructors we are having? Default or no parameterized constructor and parameterized constructor. So first is the default constructor. We'll see. Here class A I am taking. Inside class A I am defining integer A and float B, int A and float B, and I am taking one method void f1 method of return type void, and here A equal to 10, I am assigning A equal to 10, B equal to 7.8 f, and I am taking one default constructor, means here it is defined in this way. Default constructor is defined in this way. Here A is the default constructor. Inside the default constructor, I am assigning A assigned to 17 and B is assigned to 32.6f, and I am printing A. System.out.println A equal to A and B equal to B. Then inside the main method, I am creating an object. Here automatically for the default constructor, object is created. A OA equal to new A and A OA1 equal to new A. That is, automatically object will be created for the default constructor. No need to invoke the constructor explicitly. If you run this program, then what is the output you get? You get A equal to 17. That is, whenever here object OA is created for this automatically, for this default constructor, then the control goes into this default constructor, and these values of A equal to 17 and B equal to 32.6f are printed as output. So this is about default constructor. And next one is we'll see the user defined constructor. What is user defined constructor? User defined constructor is nothing but the constructor which is the default constructor which is defined by the user, which is having no parameters again. Here class B I am taking. Inside class B, integer A and float B. This is the default constructor. This is a system defined constructor because this is a dummy constructor. It has no body part. This is a system defined constructor, and this is a user defined constructor B of integer x and float y. And A is assigned to x, B is assigned to y. In system.out.println A equal to A and B equal to B. Then void f1 I am taking here, system.out.println this is f1. Then inside the main method, the object of constructor B is created, B OA1 equal to new B, and the parameters are passed here, 13, 34, some 34.6f, and B OA2 equal to new B of 44 comma 45.38 and B OA3 equal to new B. Then OA3 dot F1. What is happening here? The F1 method is invoked with this default with the object of the default constructor. So what happens? The control goes to the F1 method and this is printed. First, here what happens when object for this user-defined constructor OA1 is created, then the object is created automatically. So the control goes into this parameterized constructor and first the values of A and B are printed and next the control goes to F1 and this is F1 is printed. So we'll see the output now. See, first the values of A equal to 13, 34.6 and A equal to 44 and 45.3 is printed and then this is F1 is printed. So this is your user defined constructor and next is parameterized constructor. Now what is parameterized constructor? Parameterized constructor with object as reference, passing object as the argument. So class C is taken, inside class C integer x, float y, double z. And this is a system defined dummy constructor which is having no body part. And this is the parameterized constructor where object of C is passed as argument inside it. And here x is equal to obj dot x, y equal to obj dot y, z equal to obj dot z. Then system dot out dot println x equal to x, y equal to y, and z equal to z. Then inside the main method, first the control comes here. C OC equal to new C, that is the object for the constructor is automatically created, and then OC dot x equal to 12, OC dot y equal to 45.6f, OC dot z equal to 234.5. Then C OC1 equal to new C of OC. When the object of this constructor is created, the control goes here and automatically the values of this OC dot x, that is 12, 45.6 and 234.5 are stored here and they are printed as output. So we'll see the output of this. So x equal to 12, y equal to 45.6 and z equal to 234.5 is printed. So this is about constructors. We have seen the types of constructors also. Okay, I'll continue in the next video. Thank you. Hello everybody. Today I'm going to discuss about static block. Now, what is a static block? Whatever the statements are written within the static block, only those will be executed by the operating system by first. That is, even though if you write a main program or main method inside a class, whatever the statements are written within a static block, only those will be executed by the operating system by giving the first priority. That is, any Java program contains static block, those statements are executed first before the execution of the main method. That is, without writing the main method also, any Java program can be executed using the static block. And this I will show you with an example of the static block. So here I am taking a class ABC. Inside that I am taking one static block. I am printing system.out.println welcome. Then inside the main method class, I'm creating an object for ABC A equal to new ABC. Then system.out.println hello world. So which method will be first executed? As I had created an object for ABC class, the control goes into the static block first, and then first welcome will be printed, and then the control comes here and hello world will be printed. So we'll run this output. So first welcome will be printed and next hello world will be printed. So this is about the static block. Then next I'm going to discuss about this keyword. Now what is this keyword? This is a keyword in Java which represents the current class object. That is, this keyword can be used in two different ways. That is with respect to data members and with respect to constructors. What is this keyword with respect to data members? Whenever data member of class and formal parameters of the either method or constructor are same, then the system will be in ambiguity. Then to overcome this problem of ambiguity, this keyword is used. Whenever any data member is referenced by this keyword, that is the class variable or the data member of the class. In this keyword with respect to constructors, we can access or call any constructor within another constructor also using this keyword. So this can be used to call either parameterized constructor within another constructor of the same class. That is, this is a special member method. The scope is within the class only. That is, it can be accessed or used within the class only. And whenever data members of the class and formal parameters of the constructor are same, the system will be confused. And to differentiate this, we are using this keyword. And this is used to call any constructor within this another constructor of the same class. So now I'll show an example for this. I'll show an example for this keyword. This is the example for data members. That is, this is the example for this keyword for data members. That is class test I am taking here. Inside it I am defining int a, and test constructor I am taking the constructor test with parameters int a, and these are the formal parameters of this a is the formal parameter, and this integer a is the actual parameters of the class. So both are same, both are represented as a. So the system will be confused. So to avoid this ambiguity, we use this keyword. That is, we represent the integer a as this dot a equal to a, and system dot out dot println local variable a equal to a. And inside the main method, I'm creating an object for test class, test t equal to new test, and passing parameter 50. Then the control goes here, and the a is substituted with 50, and first the local variable 50 is printed, then the class variable is printed. So we'll run this program. See, first the local variable a equal to 50 is printed, then only the class variable 50 is printed. So this is a program for this keyword with respect to data members. Next we'll see this keyword with respect to constructors. So class, this example again, string s equal to, here I'm taking the string s equal to Java and I'm defining a constructor, this example. System inside that I'm printing system dot out dot println. This is no parameterized constructor. And one more parameterized constructor I am taking this example of string s. And here as the first statement I am passing this keyword. Why? Because this should always be first statement inside the constructor, inside another constructor. This keyword should always be the first statement inside another constructor. and this dot s equal to s, then system dot out dot println, this is a parameterized constructor, system dot out dot println, this dot s equal to this dot s. Then once the control goes into the main method, first I am creating an object for this example, t equal to new, this example of hello. So first this is a parameterized, first we are passing a parameter into this constructor, so control goes into this parameterized constructor first. As this is the first statement inside this parameterized constructor, once you see this keyword, the control goes into this default no parameterized constructor, and this statement is printed first. This is no parameterized constructor. Then the control comes back here, this dot s equal to s, uh, and then the next this is parameterized constructor is printed, and this dot s equal to this dot s, that is hello is printed. So we'll see the output of this. See, first the control went into parameterized constructor. Then the control went into no parameterized constructor, and this is no parameterized constructor is printed first. Then this is parameterized constructor is printed. Then this dot is equal to hello is printed. So this is about this keyword. Next is inheritance. I already explained about inheritance. Now, what do you mean by inheritance? It is a mechanism used to extend the properties of one class into another class, or one class acquiring a properties, or the parent class acquiring the child class acquiring the properties from its parent class is known as inheritance. Advantages of inheritance are reusability, redundancy of code is reduced, and using inheritance there is no wastage of memory. And the class giving the properties to another class is known as superclass or base class or parent class, and class taking the properties from parent class is known as derived class or subclass or child class. And we have seen the types of inheritance: single inheritance, multi-level inheritance, multiple inheritance, hierarchical inheritance, and hybrid inheritance. This multiple inheritance is not supported in Java at the class level. It is supported only through interfaces. So aggregation also I have discussed. If a class have an entity reference, then it is known as aggregation. And aggregation, that is, if a class is having another class reference, then it is known as aggregation. Aggregation represents the has a relationship, and code reuse is also best achieved by aggregation when there is no user relationship. And inheritance should be used only if the user relationship is maintained. Otherwise, aggregation is the best choice. Now, what is method overloading? Okay, I'll continue. I'll continue in the next class. Thank you. Hello, everybody. I'm going to discuss about method overloading. What do you mean by method overloading? Whenever any method is existing multiple times with the same name, different type of parameters, different number of parameters, and different order of parameters, then it is known as method overloading. And the scope of the overloading is within the class only. What is constructor overloading? Whenever any constructor is existing multiple times inside a class with a different number of parameters, different type of parameters, different order of parameters, it is known as constructor overloading. And what do you mean by overriding? Whenever the same method name is existing multiple times in the base and the derived class with the same type of parameters, same number of parameters, and same order of parameters, then it is known as overriding. And this always can be done only with the methods only. Overriding can be done only with the methods only. Overriding concept cannot take place in the constructors because scope of the constructor is within the class only. So this always can be done only with the methods but not with the constructors. So whenever same method with the same signature is existing in both the base and the derived class, then first priority is given to the derived class method while calling the method with reference of the derived class object. So now I will show you the example for this method overloading and overriding. So this is an example for overloading. I'm taking one class adder. Inside that adder, I'm defining one static integer int add method of parameters int a comma int b. I'm returning a plus b, and static double add of double a comma double b. I'm returning a plus b. Now see here, the method name is same, but uh, there are different type of parameters and different number of parameters and type of parameters are different. So this concept is known as overloading, and this takes place within a single class only. And when I have taken one main method, I am printing system.out.println adder.addout and passing 11 comma 11, and system.out.println adder.add of in the place of double a double b, I am passing it as 12.3 and 12.6. We will see the output of this program. So first 11 plus 11, 22 will be printed. The next 12.3 plus 12.6. When adder.add of 11 comma 11 is invoked, the control, since it is a static method, the object is not created. The methods are directly invoked with the class name. So the control goes into this method first, then 11 plus 11, 22 is printed here. Then next, the control goes into this into the second method, and then 12.3 plus 12.6 is added and it is printed as 24.9. Then next we'll see the what is method overriding. Overriding, here I'm taking one class bank. Inside that I'm taking one int get rate of interest and returning 0. I'm creating one child class SBI extends bank. The method I'm defining as int get rate of interest and returning 8. I'm taking one more class ICICI extends bank int get rate of interest return 7. I'm taking one more class Axis extends bank int get rate of interest return 9. Then inside the main method, now here in the what is overriding here? Overriding means the same method is there and same type and number of parameters are not taken here, but same the signature and body of the method, everything is same, and it takes place in different classes. So it is method overriding. So I'm creating an object for SBI, S equal to new SBI, and ICICI I equal to new ICICI, Axis A equal to new Axis. Then system.out.println SBI rate of interest is S dot get rate of interest. Once S dot get rate of interest, the control goes into the SBI class, and this return 8 is printed here. The next control goes here into ICICI and return 7 is printed. The next control goes into Axis and 9 is printed. Then we'll see the output here. Eight, 7 and 9 is printed. And this is about overloading and overriding. Next we'll see what is a super keyword. Now super is a keyword in Java which is used to differentiate the base class properties with the derived class properties. That is, super is used whenever inheritance is existing. That is, whenever inheritance is there, then only super keyword comes into existence. And it is used to differentiate the base class properties with the derived class properties. Whenever data members of base class and formal parameters of method or constructor of derived class is same, then the system gets into ambiguity. To overcome this problem, super can be used. And whenever we want to call constructor of the base class into constructor of the derived class, then super method can be used. And super method can be used at the method or the constructor level. Super dot or super method should be the first statement of the method or the signature. I'll show you this example for super keyword. Say first class person is taken, inside that int id string name. I define a constructor person with parameters. This is a parameterized constructor. Int id and string name. And this dot id equal to id, this dot name equal to name. I have taken on child class emp extends person. Inside that float salary and constructor emp of parameters int id string name and float salary. Then super of id comma name. So once the control goes into the main method, but first the object for this emp even is created here. Then the control goes into the emp constructor, and here super of id comma name is there. So once it sees the super of id comma name, the control goes into the parent class constructor, and the values and values are replaced here with this dot id and this dot name. This dot id and this dot name values are replaced here, and then the control comes back here, and this dot salary is taken as 45,000. And inside the event dot display, when you call event dot display, when you invoke the display method, control goes here, and id name and salary are printed. So we'll run this program. Okay, id name and salary are printed. This is about the super keyword. Next is the final keyword in Java. Now, what do you mean by final keyword? Final keyword can be used before a data member to make a variable as a constant. That is, if you use a final keyword before a data member or a variable, then it makes a variable as a constant. It cannot be varied or altered. Final data members cannot be varied or altered. And final keyword can be used before a class to restrict inheritance. That is, final class cannot be inherited. And final keyword can be used before a method to restrict overriding. That is, final methods cannot be overridden. And what a static final variable that is not initialized at the time of declaration is known as static blank final variable. That is, if a final variable is not initialized, then it is said to be as blank final variable. Then what is static final blank final variable? If a static final variable that is not initialized at the time of declaration is known as static blank final variable, and it can be initialized only in the static block. So I show this with the example. Final method and final class. So this is a class bike is defined. Inside that I'm applying final keyword to this run method, and I'm taking one more class, child class here. Final method extends bike and void run system.out.println running safely with 100 kmph. Inside the main method, I'm creating an object for this child class. I'm invoking the run method. Once I invoke the run method, we get a compile time error. Why? Because this final method cannot be overridden. So this is the example for final method. Next is final class. Here final class bike is taken. Final class bike is defined. Next, this is bike is a parent class, and next final class is the child class which extends bike. And defining a run method here. System dot out dot println running safely with 100 kmph. Inside the main method, I am creating an object for final class if equal to new final class. When I invoke the run method with the final class object, this you get a compile time error. Why? Because final class cannot be extended. So I conclude here and I'll continue in the next class. Thank you. Hello everybody. Now I'm going to explain about abstract class. If any class contains complete methods, or it is also known as concrete methods, then it is known as concrete class or abstract class. If any class contains concrete or complete methods, it is known as concrete class or abstract class. If any method is having both signature and body part, known as concrete methods. For every concrete class, we can be able to create multiple objects, and those properties can be accessed with object reference. And if any class contains incomplete methods, that class is an abstract or incomplete class. Actually, if any class contains concrete or complete methods, then it is known as concrete class. And if any method is having or non-abstract class, if any method is having both signature and body part, then it is known as concrete method or non-abstract method. For every concrete class, we can be able to create multiple objects, and those properties can be accessed with that object reference. If any class contains incomplete methods, then that class is known as abstract class or incomplete class. And if any method is having only signature part but no body part, then such method is known as abstract method. And we cannot create an object for the abstract class. An abstract class contains abstract as well as non-abstract methods. I'll show you this with the example. Here, abstract class. If a class is defined with an abstract keyword, then it is said to be abstract class. Abstract class bank 1. Begin inside that I am defining an abstract method, abstract int get rate of interest. Then class HDFC extends bank 1. This is a child class. Begin int get rate of interest, begin return 7. In class PNB extends bank 1. Begin integer get rate of interest, begin return 8. Then class abstract. Inside this main method, first I'm creating a reference for this bank 1. Why? Because bank 1 is an abstract class. I'm not creating an object for the abstract class. I'm just creating one reference for this bank 1. Then using that reference, I'm creating the object for HDFC class. Then system.out.println, I'm accessing the method in the HDFC class using this abstract reference b dot get rate of interest, b equal to new PNB. System.out.println rate of interest is b dot get rate of interest. We'll see this output. Okay, rate of interest is 7% and rate of interest is 8%. The next one is the interface. Now, what is an interface? An interface is similar to a class, which is a collection of data members and abstract methods, and it can be represented with interface keyword. Interface is also similar to a class, and it is a collection of data members and abstract methods, and it is represented with the interface keyword. That is, interface can contain only abstract methods. Interface contains only abstract methods. It cannot contain non-abstract methods. And data member of interface must be initialized. An interface contains only abstract methods. Every method of interface can be declared with or without using abstract keyword. That is, it is not compulsory that method of interface should be declared with abstract keyword only. It can be with or without using abstract keyword. The method can be with or without using abstract keyword also. An interface which has no member is known as marker or tagged interface. And what are the examples for marker interfaces? Serializable, clonable, remote, etc. That is an empty marker interface is an empty interface which has no body part. And the examples for marker interfaces are serializable, clonable, and remote, etc. So here I'm defining an interface drawable. Inside that I am defining one method, abstract method. Here, even though if you don't define with abstract keyword, this becomes an abstract method only. Void draw. Next class rectangle implements drawable and public void draw. Now I am implementing this draw method inside this rectangle class. Public void draw begins system.out.println drawing rectangle. Class circle implements drawable public void draw system.out.println drawing circle. Then inside the main method, what is happening? I am creating an object for this interface drawable d. I'm creating just a reference for this interface drawable d equal to and I'm creating an object for this circle class, new circle. Then using this reference, I am invoking the draw method. So what will be the output of this? Only drawing circle. Why? Because I am invoking only the draw method of the circle class. So that's why we get only drawing circle here. Next is the packages. And packages are the special containers, which are packages are nothing but they are the collection of classes, interfaces, and sub-packages. And the sub-package is also a container, which is also a collection of classes, interface, and sub-packages. So packages always should be in lowercase, and these are created whenever multiple users want to access the same properties repeatedly multiple times. And so that redundancy of the code can be reduced and time taken process to develop and execute the code is less. So what are the advantages of these packages? Packages are created whenever multiple users want to access the same properties repeatedly multiple times so that redundancy of the code can be reduced and time taken process to develop and execute the code is less and wastage of memory will be reduced. So I'll show you the example for these packages. This is one package, public class package. This is the one package, com.core java is one package. Here public class package inside a public void message and method I'm taking and printing system.out.println help. And this is another type of package. I'm importing com.core java. You can take one more package and import the package in this present package also. Next is the access specifiers. Now, what are access specifiers? There are four types of access specifiers: private, protected, default, and public. Now, what is private? Private is a keyword in Java, and whenever it is preceded by by any data member or method of the class, those can be accessed within the class only. That is, private access specifiers are accessed only within the class. And protected is a keyword in Java whenever it is preceded by any method of the class. Those can be accessed not only within the class but derived class of same package and subclasses of other packages also. So protected access specifiers can be accessed not only within the class but derived class of same package and also subclasses of the other packages. And default is a keyword in Java. Whenever it is preceded by any method of class, those can be accessed anywhere in the program of same package. That is, default can be accessed anywhere anywhere in the class of the same package only. And public is a keyword in Java. Whenever it is preceded by method of the class, those can be accessed anywhere in the class of same package and other packages also. That is, public can be accessed anywhere in the same package and also other packages. So I'll show you the example for packages, sorry, access specifiers. See, this is an example for access specifier for private class. Here class A2 is taken here. Inside that I am defining one private data member as private in data equal to 40, private void message. Inside that I am displaying system.out.println hello Java. Then I am taking, this is the package name is com.core Java. In the same package I am taking two classes. One is class A2 and the other is class private example. Inside that I am defining the main method. I am creating an object for the A2 class and I am printing system.out.println object.data. So when I say object.data, the control goes here and 40 should be printed. But since this data member is private, it will give a compile time error. And similarly, the method cannot be invoked. Why? Because it gives a compile time error, and this message is given with a private key. Next is the default here. I have taken one more package, my pack here. I have created one more package, my pack. Inside my pack, I'm importing com.core Java package, and I have taken class default. I have already defined A3 class in this package. Inside the package com.core Java, I have taken one class A3 and taken one inside the class A3. I'm defining one method message which is printing system.out.println hello. And inside another package, I'm importing the package com.core Java. I'm defining one class default ex and inside the main method creating object for A3 and I am invoking the message method in this A3 class. But it will give a compile time error. Why? Because default access specifiers are accessible only within the same package only. That is why it gives a compile time error. Next is the protected. First, I have taken one package com.core Java. Inside that, I am defining one public class A4. Inside that, I am defining one protected void message system.out.println hello. I am taking one more package, my pack, and importing the original package here com.core Java. Then class protected ex extends A4. Inside the main method, I am creating the object for this protected ex, and I am invoking the message method. So since the protected access modifier can be accessed within the class and also derived class of the same package and other package also. So since this is a derived class of other package, there is no compile time error here. And similarly for public also, since public can be accessed anywhere, anywhere, so there is no compile time error for public access specifier. So I'll conclude here and I'll continue in the next video. Thank you. Hello everybody. Today I'm going to discuss about strings. The Java string is immutable, which means it cannot be changed. That is, the string class cannot be modified or cannot be changed. Whenever we change any string, then a new instance will be created. That is, if you want to go for a mutable string, then you have to use string builder, string buffer, and string builder classes. That is, if you want to change a string, then you need to go for string buffer or string builder classes. Generally, string object is a sequence of characters, and the java.lang.string is used to create a string object. Java string class provides a lot of methods to string class has lot of methods to perform operations on the strings. And what are the operations you can perform on strings? The operations like compare, concat, equal, split, length, replace, compare to, substring, etc. These are the operations you can perform on the strings. And there are three ways to compare strings in Java. First is by equals method, by double equal to, and by compare to method. The string equals method compares only the original content of the string. That is, it compares the values of the string for equality. And double equal to operator compares only the reference values. And string compare to method compares values lexicographically and returns an integer value that describes if the first string is less than, greater than, or equal to the second string. In Java, string concatenation forms a new string. That is string concatenation is a combination of two new strings, or it is a combination of multiple strings. And there are two ways to concat string in Java. That is by using the plus operator and by concat method. And a part of the string is known as substring. In other words, substring is a subset of another string. In case of substring, what happens? The start index is always included, but the end index will be excluded. And java.lang.string class provides a lot of methods to work on the string. Just now we have discussed the string java.lang.string class provides a lot of methods and with the help of these methods, we can perform operations on the string. And what are these operations? Operations like trimming, concatenating, converting, comparing, replacing the strings, etc. Now, what is a string buffer? Java string buffer class is used to create mutable or modifiable or changeable strings. That is, you can modify or you can change the string content. The string buffer class in Java is same as the string class, except that what is the difference between string and string buffer? String is immutable, which cannot be changed. The contents of the string cannot be changed, whereas string buffer is mutable. That is, its contents can be changed. And string that can be modified or changed is known as mutable string. String buffer and string builder classes are used for creating the mutable strings. And there are some methods for this string buffer. We'll see what are those methods. The first one is the append method. What does this append method do? Append method concatenates the given argument with the string. That is, the append method concatenates the two given strings. And the insert method inserts the given string with its string at the given position. And the replace method replaces the given string from the specified begin index and end index. And the delete method of string buffer class deletes the string from the specified begin index to end index. The reverse method of the string builder class reverses the current string. Now next one is the string builder. Java string builder class is also used to create a mutable or modifiable or a changeable string. And Java string builder class is same as string buffer class except that it is non-synchronized. Now what is the difference between string buffer and string builder? String buffer is synchronized. It is thread safe. where a string builder is non-synchronized, it is not thread safe. But the common point is that both string buffer and string builder are mutable or modifiable strings. And the string builder has also some methods. We'll see what are those methods. It is having append method that concatenates the given argument with the string. String builder is also having insert method that inserts the given string with a string in the given position. And replace method replaces the given string from the specified begin index to the end index. And delete method of string builder class deletes the string from the specified begin index to end index. And the reverse method of string builder class reverses the current string. Okay, I conclude up. Okay, now we'll see some examples of this programs on the strings. Okay, now we'll see some examples on the strings. Now, what is string equals? Just a minute. Okay, now we'll see this example of string equals. What is string equals? It is used to compare the contents of the string for contents of the string, that is, it will check for equality. Class string equals in the main inside the main method. I am taking the string s1 equal to Sachin. String s2 is also equal to Sachin. Now see whether these strings are case sensitive or insensitive. String s3 equal to new string of Sachin. Now what is happening in this case of string s3? In the case of string s3, I am creating a new string object, because since I am using a new keyword here, I am creating a new string object here. String s4 equal to Saurav. Now system.out.println s1 dot equals s2. Is it true? Yeah, s1 dot equal s2 is true. System.out.println s1 dot equals s3. s1 dot equals s3. Yeah, both are Sachin. Even though string s3 is a new object because we are creating s3 using the new keyword, but the values are equal, Sachin and Sachin. So it is true. In system.out.println s1 dot equals s4 is false. So we'll run this and see. See the output true, true, and false. Okay. Next we will see string double equals. Now in this program, public class string double equals. What does the double equal operator do? Double equal operator is used to compare the check the compare. It is used to compare the reference value, reference type, not the values but the reference type. So here string s1 equal to Sachin, string s2 is also equal to Sachin, but string s3 is a new object. Why? Because is an object which is is a new object. Why? Because it is created using the new keyword, new string of Sachin. Then system.out.println s1 equal to s2. Yeah, it is true because both the reference types are same. Because both refer to the same instance. And system.out.println s1 equal to s3 is false. Why? Because since s3 refers to the instance created in the non-pool, s3 is a new instance. So that is why it is false. We'll run this program and see. Yeah, it is true. Output is true and false. Next is string compare to. In this program, string compare to. In the main method, string s1 is Sachin, s2 is Sachin, string s3 is Ratan. Then system.out.println s1 dot compare to of s2 is compare to returns an integer value. It does not return a boolean value, whereas the equals method and the double equal operator returns boolean values, but compare to method returns an integer value. Since both are true, it is returning 0. And s1 dot compare to of s3, since it is false. Why? Because since s1 is greater than s3, s1 is greater than s3, it returns 1. If s1 is greater than s3, it returns 1. If s1 is less than s3, it returns minus 1. See here, s3 dot compare to of s1, since s3 is less than s1, it returns minus 1. Okay, we'll run this program and see. If it is equal, it returns 0. 0, 0. Since s1 equal to s2, it returns 0. Since s1 is greater than s3 it returns 1. Since s3 is less than s1, it returns minus 1. Okay. Then it's a string concat. We'll run this program in the string concat string s equal to Sachin plus Tendulkar. Here string cannot be modified or string is immutable. So can we concat this both the strings? We'll run and see this program. Yeah, it can be concated using plus operator. Okay. We run this program and see. Yeah. So concat is used to concat the two strings. So how can you concat two strings? Either you can concat using the plus operator or you can concat using concat method. Then next we'll go to string buffer append method. Now what is happening here in the string buffer append method? Inside the main method, I am creating an object for string buffer. String buffer sb equal to new string buffer. I'm passing a string inside it, hello. Then I'm saying sb dot append of Java. Now original string is changed. System.out.println sb. So append means what? See here, actually the given string is hello, and this we are appending Java after hello. Append means the string which needs to be appended will be inserted at the last position. So it prints hello Java. Append means always it inserts in the last. See the output hello Java. Next we'll see string buffer delete. In the string buffer delete, string buffer I'm creating an object for string buffer sb equal to new string buffer of hello. Then sb dot delete of 1 comma 3. What does this delete do? This 1 is the starting index, 3 is the ending index. So the always starting index will be included, ending index will not, will be excluded. So 1 to 2 positions will be deleted. So E and L will be deleted. So it will print HLO. See here, H always the string starts with index 0, 1 and 2. So 1 and 2 means E and L will be deleted. And third index will be excluded. It will not be deleted. So the output will be HLO. See the output. Next is string buffer insert. In this program, string buffer insert inside the main method, creating an object for string buffer sb equal to new string buffer of hello. Then sb dot insert of 1 comma Java. Now what it will do? At the position 1, it is inserting Java. Where is the position 1 here? 0 is H, 1 is E. So after H, it will insert Java. Okay, see after H, after 0, Java is inserted. Next, string buffer replace. In this replace method also, sb dot replace 1 comma 3 comma Java. What happens here? Starting index is 1, ending index is 3, and we have to replace with Java. So 1 means 0, 1. 1 is E, L is 2. So EL should be replaced with Java. Okay, EL will be replaced. 1 and 2 will be replaced with Java. Next, string buffer reverse. In string buffer reverse, what is happening? Creating an object for string buffer sb equal to new string buffer of hello. Then sb dot reverse means this hello will be reversed. Reverse means the last index will become first. It will be reversed. OLLEH. Output will be OLLEH. Next we'll see what are string builder methods. This is the string builder append method. So I'm inside the main method I'm creating the object for string builder sb equal to new string builder of hello. Then sb dot append Java. So where does it appends? It appends after hello. Always append function will insert in the last. Okay, the output is hello Java. Next is string builder delete. Here also string builder sb equal to new string builder of hello sb dot delete 1 comma 3. 1 comma 3 means 1 is the starting position, 3 is the ending position. So 1 and 2 will be, 1 is included, 3 is excluded. So 1 and 2 will be deleted. What are 1 and 2? E and L will be deleted. So HLO will be your output. Next is string builder insert. Here also sb dot insert 1 comma Java. That is after the first position Java will be inserted. That is at the first position Java will be inserted. So 0 is H. So At the first position, Java will be inserted. After H, Java will be inserted. This is the output. Next, string builder replace. Here also string builder sb equal to new string builder of hello sb dot replace 1 comma 3 comma Java. So what is happening here? The starting index is 1, ending index is 3, and the replaced string should be Java. That is 0 is H, E and L. 1 and 2 should be replaced with Java. That is E and L should be replaced with Java. We run and see the program. So E and L will be replaced with Java. Next, string builder reverse function. This is also same. String will be reversed. Next, substring. What is substring here? Here string S I am taking a Sachin Tendulkar. Then system.out.println s dot substring of 6 means it will take the substring from this given string from the position 6. 0, 1, 2, 3, 4, 5, 6. 6 is T. So from T it will extract the string, complete string, that is Tendulkar. Here 0, comma 6. 0, comma 6 means it will extract from 0 to 6. So it is 0, 1, 2, 3, 4, 5 and 6 will be excluded here. So it will extract from 0 to 5. So Sachin will be extracted. See the output. Yeah, Tendulkar and Sachin. So this is about strings. So now I conclude here. I will continue in the next class. Thank you. Hello everybody. In this class, I am going to discuss about arrays. Java array is an object which is used to store the elements of a similar data type. That is, array is an object which stores the elements of similar data type. And these elements are stored in a contiguous memory location. And the array is also a data structure where we can store only a fixed set of elements. That is, the array elements are fixed. They cannot grow. Array cannot grow. So and also array in Java is an index based. That is, the first element of the array will be stored at the 0th index. First element will be stored at first index, and second element will be stored in the array in Java is index based. That is, the first element of the array is stored at 0th index. Second element is stored at first index, and third element is stored at second index, and so on. So what is the advantage of array? Array makes the code optimized, and we can also retrieve the elements using array, and we can sort the elements also. And we can also get the data located in the array at a particular index position. And so array does not grow its size at runtime. So this is the disadvantage of array. So to solve this problem, there are collection frameworks in Java, so that which grows automatically. And we can also print the arrays using for each loop. That is, the Java for each loop prints the array elements one by one. And Java Virtual Machine also throws an array index out of bounds exception if the length of the array is negative, equal to, or greater than the array size while traversing the array. So now we'll see some exercises or programs related to arrays. And there are two types of arrays we are having: single dimensional array and multi-dimensional array. So this is an example for array. Inside public class array, I'm defining the main method public static void main string args. I'm defining an array here. How will you define an array? This is the data type int a array equal to, these are the elements of the array 33, 3, 4, 5. This is known as instantiation, initialization, or declaration of an array. Then how do you print the array? You can print the array using the for loop. For int as I assigned to 0, I less than a dot length. A dot length means array dot length. A is the array here, and I plus plus. Then system dot out dot println a of I, so that uh, this array elements can be printed. See, these are the array elements 33, 3, 4, and 5. Next, we'll see a multi-dimensional array. How do you denote a single dimensional array and how do you denote a multi-dimensional array? We'll see the difference. What is the difference between single dimension and multi-dimensional? This is public class array multi-dimensional. Then inside that I'm defining the main method public static void main string args. See here how to initialize, instantiate, and declare a 2D array. 2D means two-dimensional array. Int array, two-dimensional means you should use two braces here. Three-dimensional means you should use three braces. One-dimensional means you should use only one brace. Equal to flower braces 1, 2, 3, 2, 4, 5, 4, 4, 5. Then how to print a two-dimensional array? You should use two for loops here. For int I assigned to 0, I less than 3. This 3 is the number of rows. Number of rows is the total number of elements in the array. And I plus plus begin. For this is the second for loop. For int j assigned to 0, j less than 3, j plus plus. This 3 is the number of columns is the number of the elements in the first 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 dimension, that is 1, 2, and 3. Okay, then begin system dot out dot print array of I j plus space. Then end the first for loop. Then system dot out dot println. That is, to print an array, you need to print it in the form of an array. That is why you use the system dot out dot println here. See, how do you print an array? First 1, 2, 3 will be printed here. Then next, it will go to the next line. Then 2, 4, 5 will be printed. It will again go to the next line. Then 4, 4, 5 will be printed. So this is a multi-dimensional or a two-dimensional array. Then for each loop, how to use a for each loop in arrays? Public class array for each begin public static void main string args begin integer. This is a single dimensional array or one dimensional array. Integer array is equal to 33, 3, 4, 5. Then how do you print array using for each loop? For int I colon array. Okay. For int I colon array system dot out dot println I. This will traverse through the array and it will print one by elements one by one. See the output here. Next is the exception. What are the exception raised in arrays? Array index out of bounds exception. So array exception begin public static void main string args begin integer single dimensional array equal to 50, 60, 70, 80. Then for int I assigned 0, I less than or equal to array dot length. Actually, here the length of the array is from 0, I assigned to 0 and I less than array dot length. But here we are keeping equal to here. That is, we are taking one dimension extra. So that is why it will give array index out of bounds exception when you print this array. So we'll see the output what you get. So see here, we are getting a java.lang.array index out of bounds exception. Okay. So this is about arrays. So I'll continue in the next class. Thank you. Hello everybody. Today I'm going to discuss about wrapper classes. The what are wrapper classes? Actually, the wrapper classes are nothing but they are used to convert primitive data types into objects and also objects to primitive data types. That is the there are two concepts you need to know here. There is a feature known as auto boxing. Auto boxing is nothing but it is a process to convert primitive data types into a wrapper class object. And there is another feature known as unboxing. That is is a vice versa process. That is it converts wrapper class object into primitive data types. So the automatic conversion of primitive into wrapper class object is known as auto boxing and vice versa is unboxing. That is auto boxing means, for example, auto boxing is from primitive data types to automatic conversion of primitive data type into its corresponding wrapper class object is known as auto boxing. That is primitive type means this byte. Byte is the primitive type. The wrapper class object is this capital byte. And char is the primitive type to character. And int is the primitive type to integer. Long is the primitive type to long. Float is the primitive type to float. And boolean is the primitive type to boolean. Double is the primitive type to double. And short is the primitive type converted to short. So this is known as automatic conversion of primitive data type into its wrapper class object. And this feature is known as auto boxing. And the reverse process is known as unboxing. Now we see some examples for this. What is auto boxing actually? See here in this public class auto boxing, I am defining one main method public static void main string arguments. Here I am converting. Now what is auto boxing feature? It converts primitive data types to wrapper class object. That is converting primitive type into integer object. That is int a equal to 20. So first I need to assign I need to consider a primitive data type, that is int. A is assigned to 20. Then integer is the object, integer I equal to integer dot value of A. What is this value of? Value of is for converting int to integer explicitly. Okay, but, this statement is converting int, that is A is int here, int to integer. Is converting int to integer. Then integer j is assigned to A. This feature is known as auto boxing. Now system.out.println A, I, and J. So now what are the values of A, I, and J? It will be printed in the output. See, A value is 20, I value is 20, and J value is also 20. Okay, this feature is known as auto boxing. And what is unboxing feature now? See, public class unboxing, public static void main string arguments. Now unboxing feature is nothing but converting the wrapper class object into primitive data types. That is object integer to primitive data type int. So first you need to take an integer object. Integer a equal to new integer of 3. 3 is the integer here, object. Then int I equal to a dot int value. This int value is used to convert object, that is object integer to int. Okay, then int j is assigned to a. Then system.out.println aing. So this feature is known as unboxing. See, a is 3, I is 3, and j is 3. Okay, this is about wrapper classes. I'll continue in the next class. Thank you. Hello everybody. Today I'm going to discuss about exception handling. Exception handling is a mechanism to handle the runtime errors. Exception is actually an abnormal flow of control, or it is an abnormal condition. In Java, an exception is an event that disturbs the normal flow of the program, and exception is an object which is actually thrown at runtime. And exception handling is a mechanism to handle runtime errors such as class not found exception, IO exception, SQL exception, remote exception, etc. And the root class of Java exception hierarchy is java.lang.throwable class. And the types of exceptions are, there are three types of exceptions: checked exceptions, unchecked exceptions, and error. Checked exceptions are checked at compile time. So examples for checked exceptions are IO exception, SQL exception, etc. And unchecked exceptions are not checked at compile time, but they are checked at runtime. Examples for unchecked exceptions are arithmetic exception, null pointer exception, array index out of bounds exception, etc. And the last is the error, which is an irrecoverable. That is, examples for error are out of memory error, virtual machine error, and assertion error, etc. And if an exception occurs at a particular statement of try block, then the rest of the block code will not execute. So it is better what you do, like the code which is that is, it is recommended to keep the to not to keep the code in the try block which will not throw an exception. It is better or recommended not to keep the code in the try block which does not throw an exception. And Java try block must always be followed by either a catch or a finally block. And Java catch block is used to handle an exception by declaring the exception type of exception with the parameter. And the catch block must be used only after the try block. And you can also use multiple catch blocks with a single try block. Each catch block, when you use multiple catch blocks, each catch block must contain a different exception handler. That is, when you have to perform different tasks. That is, if you get different exceptions, then you can use multiple catch blocks. That is, at a time only one exception occurs, and at a time only one catch block is executed. And all the catch blocks must be ordered from most specific to the most general. That is, catch for arithmetic exception must come before the catch for exception. And next we'll discuss about nested try blocks. The try block within a try block is known as nested try block in Java. And next is the finally block. Java finally block is a block that is used to execute an important code like closing connections, streams, etc. And Java finally block is always executed whether an exception is handled or not. That is, whether an exception is handled or not, but finally block may always execute. So Java finally block follows by try catch block. That is, finally block in Java can be used to clean up the code and closing a file, closing connections, etc. Next we'll discuss about the throw keyword. Java throw keyword is used to explicitly throw an exception. It is just used to throw an exception. and we can throw either checked or unchecked exceptions by throw keyword. And this throw keyword is mainly used to throw custom exceptions. And Java, next we'll see what is throws keyword. Java throws keyword is used to just declare an exception. That is, the Java throws keyword gives information to the programmer that an exception may occur. So it is better for the programmer to provide the exception handling code so that normal flow of the program is maintained. That is, this throws keyword, it will before only it will warn the programmer that an exception may occur so that the normal flow of the program is maintained. And exception handling is mainly used to handle the checked exceptions. If there occurs any unchecked exceptions like null pointer exception, then it is the problem of the programmer. Then what is a custom exception? If you are creating your own exception, then it is known as custom exception or a user defined exception. Java custom exceptions are used to customize the exceptions according to the user needs. That is, you can have your own exception in message. Now we'll see some of the examples for these exceptions. First, we'll say what is this try catch. Public class try catch begin. Public static void main string arguments. So inside the try method, you should put the code only which may throw an exception. You should not put the code that don't have an exception. The code which is working well should be kept outside the try block. Only the code which is not working well or which may throw an exception must be kept in the try block. Here int data equal to 50 by 0. This may throw an exception. Why? Because this we are dividing by 0. We are dividing the integer by 0. So this may throw an exception. That's why this code is kept in the try block. And how to handle this exception using the catch block. This may lead to arithmetic exception. So catch arithmetic exception E begin system.out.println E. Then system.out.println rest of the code. So now we'll run this program and see what is the output now. So first exception is handled here. Then this rest of the code is also printed. Next is how this throw works. Public class throw begin. Static void validate of int age begin. If age less than 18, throw new arithmetic exception if not valid. Else system.out.println welcome to world. So always the control starts from the main method. So first the control enters into the main method. Then it sees that there is a validate method here, validate of 13. Then the control goes to this method validate and replaces age with 13 and checks here if age 13 is less than 18. Yes, it is less than 18. So it will throw new arithmetic exception of not valid. So what is the goal of this throw keyword? It will just throw an exception. Whatever may be, it will just throw an exception. So it is throwing an exception not valid and the rest of the code will not be printed. Why? Because the control doesn't come back here. After the exception has occurred, the control doesn't come back to the main method. So not valid is printed. Okay. The next throws. What is throws? Here, sorry. Okay. What is throws? Public class throws begin. Void and throws IO exception begin. Throw new IO exception of device error. Void and throws IO exception begin. So always the control starts from the main method. So first the control enters here. throws object equal to new throws. Then object dot p. So we are invoking the p method with this object. So first the control enters into the p method. Inside the p method we have written a try block. Inside the try we have the first statement is n method. So n method is called. So control goes into the n method. Inside the n method it is saying void and throws IO exception. So what do we mean by throws IO exception? Throws is just used to declare the programmer that an exception is occurring. So it just declares the programmer that an exception is occurring. Then next the control is transferred to M method. Then again control goes here. Here void and throws IO exception. So it is declaring the programmer that an exception is occurring, IO exception. So even the throw new IO exception is thrown here, but the programmer has been declared that an IO exception is occurring. So this exception will not execute. Why? Because here already throws IO exception is there, so programmer is warned or declared that an IO exception will occur, so he will handle this exception. So this exception will not be executed. So again control comes back here and control comes back here and catch exception V control comes here and exception handle will be printed. Then after this normal flow control comes back here and normal flow will be printed. So only exception handled and normal flow will be printed. So first exception handled will be printed, then normal flow will be printed. Then what is checked exception? Public class checked exception. What are the checked exceptions you are having? Checked exceptions are file not found exception, IO exception, SQL exception. These are checked exceptions. So this is not the only unchecked exceptions are the mistake done by the programmer. And so first the control enters into the main method. Here print writer pw enters into the try block. Pw equal to new printer of jtp.text. So print writer object is created here. Then pw.println saved will be printed. Then next providing the checked exception handler. Here this may throw an exception. So that exception is handled by this catch block and this exception will be printed and file is only the exception is handled by the catch block and this statement will not be printed. So file saved successfully. So actually this exception which is thrown is handled by the catch block. So that's why the normal flow of the program is not disturbed. It is maintained. So that is why file saved successfully is printed here. Okay, so I'll stop here and we'll continue in the next class. Thank you. Hello everybody. Today I'm going to discuss about inner classes. Now, what is an inner class? Actually, in Java, inner class is also known as a nested class, and it is a class which is declared inside another class or interface. And we use inner classes to group the classes or interfaces in one place so that they can be more readable and efficient. And additionally, inner class can access all the members of the outer class, including the private data members and methods. And nested class can access all the members, that is data members and the methods of the outer class, including private also. And This code optimization, it requires less code to write. That is, inner class is used for code optimization. Now next, actually what is a nested class actually? There are two types of nested classes. One is non-static nested class and static nested class. A non-static nested classes are known as inner classes. And a non-static nested class or an inner class is divided into three types: member inner class, local inner class, and anonymous inner class. Now, what is a member inner class? A non-static nested class which is created inside a class but outside the method is known as a member inner class. Now, what is an anonymous inner class? First of all, what is an anonymous class? An anonymous class is a class which is not having any name. So, anonymous inner class should be used if you have to override the method of a class or an interface. And what is a local inner class? Local inner class is nothing but a class, a non-static nested class which is created inside a method, uh, is known as local inner class in Java. Then what is a static nested class? A static nested class is created inside a static class that is created inside a class is called as a static nested class in Java. And this static nested class cannot access the non-static data members and methods. And this static nested class can be accessed by the outer class. That is, static nested class can access only the static data members and methods including private, but it cannot access the non-static data members and methods. Now, what is a nested interface? A nested interface, that is an interface that is declared inside another interface or a class, is known as nested interface. These nested interfaces are used to group the interfaces so that they are easy to maintain, and this nested interface must be referred by the outer interface of a class. It cannot be accessed directly. And nested interface must be public if it is declared inside the interface. That is, an interface which is declared inside another interface, that nested interface must be public. And if it is declared within the class, then it cannot have any access specified. Okay, I'll show you some examples for these nested classes. Now, first of all, we'll see this example for inner class. How inner class is written here? Public class inner classes begin and taking one private variable, that is private int data, is assigned to 30. Then I am defining one inner class, that is class inner. Inside that inner class, I am defining one method void message where I am printing system.out.println data is equal to data. Then the control always starts from the main method. Once you get into main method, first the object of the outer class is created. That is, inner classes object equal to new inner classes. Then always this inner class is accessed using this outer class. That is, inner classes dot inner object in is equal to obj dot new inner. Then using this object in, I am accessing the method message in dot message. So we'll see the output. So data is 30 is printed here. Okay, output is data is 30. Now next we'll see what are non-static nested classes. Non-static nested classes are divided into three types: member inner classes, local inner classes, and anonymous inner class. First we'll see what are member inner classes. What is a member inner class? Member inner class is a class which is created inside a class but outside the method. So see here, public class member inner. I'm defining one private variable, private in data is assigned to 30. So this inner class is created outside the method. So class inner begin void message, I'm printing system.out.println data is data. Always the control starts from the main method. So first I am creating object for the outer class, that is member inner. object equal to new member inner. Then I'm accessing this inner class using this outer class. That is member inner dot inner. Again object in is equal to obj dot new. Then I'm using this object in. I'm invoking the message method. So this class inner is created outside the method. That is why it is known as member inner class. Now we'll see the output of this program. So data is 30 is the output. Next we'll see what is the other one. Other type is the local inner class. Now what is this local inner class? Local inner class is an inner class which is created inside the method. That is known as local inner class. So see here public class local inner. I am defining one private variable, private in data assigned 30. Then first I am defining a method void display. Inside that method I am defining the local inner class. That is class local begin void message and printing system.out.println data. End the class, and then inside this method only I am creating the object for the inner class local L equal to new local, then L dot message. Okay, then means always control starts from the main method. So first the object for the outer class is created, that is local inner object equal to new local inner. Using this object I'm invoking this display method. So object dot display. So 30 is the output here. Next we'll see what is this nested interface. An interface which is defined inside another interface or a class is known as nested interface. So here I am defining an interface showable, then begin. I am defining one method void show. Then inside this outer interface I am defining an inner interface message, again begin void message. Then always the control starts from the main method. So class nested interface implements the showable dot message. Always the class implements the interface. So first the outer interface, then dot inner interface. Begin. Public void message, then system dot out dot println hello nested interface. So always the control starts from the main method. So once the reference of object cannot be created for an interface. So just an instance is created here. Showable dot message is equal to new. Using that instance, we can create an object for this class, nested interface, new nested interface. Then using this instance message, I am invoking the message method, message. So we'll see the output of this. You cannot directly create an object for an interface. We need to first create an instance, and using that instance, you can create an object for that class. So your output is hello nested interface. So this is about inner classes. So I'll continue in the next class. Thank you. Hello everybody. Today I'm going to discuss about multi-threading. Now what is multi-threading? Multi-threading in Java is the process of executing multiple threads simultaneously. That is multiple threads are executed at the same time simultaneously. And thread is a small lightweight process, and thread is a smallest unit of processing. And this multi-processing and multi-threading both are used to achieve multitasking. Now, what is this multitasking? Multitasking is nothing but suppose a person is performing some operations on a computer. That is, he's checking mails and at the same time he is taking some printouts. That is, printer is also working. That is, both the operations can be performed simultaneously. This process is known as multitasking. And however, we use multi-threading and multi-processing because That is, threads share a common memory area, and threads don't allocate a separate memory area for each thread. For this reason, thread saves memory, and that is, it takes less time to process the threads also. And Java multithreading is mostly used in games, animation, etc. And for example, if you consider a process and a thread, a process allocates separate memory area for the process, and it takes more time to process execute a process, and time taken is more, and yeah, the cost is also more. Whereas for a thread, the thread allocates a shared memory area, and the time taken to execute a thread is less, and it is also less expensive. And it does not block the user because threads are independent, and you can perform multiple operations using the threads simultaneously, so that it saves time. And threads are independent. Why? Because they don't. If one exception occurs, the other threads are not affected. Means they do not affect the other threads if an exception occurs. Now, what is this multitasking? Multitasking, as I said, it is a process of executing the multiple tasks simultaneously or at the same time, and we use multitasking to utilize the CPU. Multitasking can be achieved in two ways: using multiprocessing, that is process-based multitasking, and multi-threading, that is thread-based multitasking. Now, what is this process-based multitasking? As I said, in this process-based multitasking, each process shares a separate address in memory, and that is, each process allocates a separate memory area, and process is a heavyweight also, and cost of communication between two processes is also very high, and it requires more time for to switch from one process to another, and etc. Whereas in thread-based multitasking, the thread share the common address base, and thread is lightweight, and cost of communication between the thread is low. Now, what is a thread actually? Thread is a lightweight process, and it is a separate path of execution. That is, threads are independent. Independent in the sense, if an exception occurs in one thread, it does not affect the other threads. And Java has a class known as thread class, which is used to achieve the thread programming. This thread class has some constructors and methods to perform which performs operations on the threads. So this thread class extends the object class and implements the runnable interface. Now, what is the life cycle of a thread? Thread can be in the life cycle of the thread is of 5 states. Now, what are these 5 states? The 5 states are: first one is the new state, second one is the runnable state, third one is running state, fourth one is non-runnable or blocker state, and the last and the fifth one is the terminated state. This life cycle of the thread is Java is controlled by JVM. Now, how to create a thread actually? There are two ways to create a thread. One is by extending the thread class, and the second method is by implementing the runnable interface. And these are the commonly used constructors of the thread class. Now, what is this runnable interface? Runnable interface should always be implemented by the thread class. And this runnable interface has only one method known as run method, that is public void run. Public void run, which is used to perform the action for the thread. What is starting of a thread? How the thread starts? It starts using the start method. The start method is used to start a new thread, and then the second life cycle method is runnable state. That is, thread moves from the start method to the runnable state, and the third method is the running state, and the next method, fourth method, is the non-runnable or the blocking state. And the last one is the terminated state. That is, when the thread is executing, the run method will run. Okay, now what is this thread scheduler? Thread scheduler in Java is a part of JVM that decides which thread to run. That is when the thread should run and which thread to run. And once the only one thread can be run, only one thread can be run at a, during a single process. And this thread scheduler mainly uses the preemptive or time slicing scheduling to schedule the threads. That is, thread scheduler schedules the threads to run. And the sleep method of thread class is used to sleep a thread for a specified amount of time. Sleep method makes the thread to sleep. And the thread class provides two methods for sleeping a thread, that is public static void sleep, throws interrupted exception, and public static void sleep. These are the two methods. The sleep method is having the two methods. Then after starting a thread, it cannot start again. That is, if you start a thread for the second time, it will throw an illegal thread state exception. Then next is the join method. What is the join method? The join method waits for a thread to die. That is, in other words, it makes the currently running thread to stop executing, and the other thread which will join will complete the task. Next is current method. The current method returns a reference to the currently executing thread object. Next, naming the thread. How do you name a thread? We can name a thread using the set name method. That is, thread class provides methods to change and get the name of a thread. That is, thread is also having some names like thread 0, thread 1, and so on. And we can change the name of the thread by using the set name method. So I will show you some examples. First is this thread example. Actually, how the program is public class thread example extends thread. Inside that, I am defining one run method, public void run, and printing system.out.println thread is running. So always control starts from the main method. First, the object of the class is created, thread example t1 equal to new thread example. Then I'm invoking the start method using the thread object t1. So we'll see the output of this. So once the start method is invoked, the control jumps into this run method and thread is running is printed in the output. Next, naming the thread. How the thread can be named. So public class naming thread extends thread and defining one run method, public void run, and printing system.out.println running. So always the control enters into the main method, that is the control starts from the main method. First I am creating two objects for this class naming thread. That is naming thread t1 equal to new naming thread t2 equal to new naming thread. Then I am printing system.out.println name of t1 equal to t1.getName. That is, you can get the name of the thread using getName method. And you can change the name of the thread using setName method. Then again system.out.println name of the thread t2 is t2.getName. Then I am invoking the method start methods using these two objects t1.start and t2.start. Then I want to change the name of the t1, so I should write as t1.setName. So no choice. Then system.out.println after changing the name of t1, the name is t1.getName. So we'll run this program. So first the name of T1. First this statement will be printed. Name of T1 is thread 0. And next this statement will be printed. Name of the T2 is thread 1. Then after changing the name of the T1, what you will get? T1 name changes to Sonu Jays. And this is current thread. That is public class current thread extends thread. Inside the public void one, and printing system.out.println thread dot current thread dot getName. Current thread is used to give the current thread object. That is which thread is running currently, that object will be printed. Inside the always control starts from the main method. So current I'm not creating two objects for the current thread T1 equal to new current thread T2 equal to new current thread. Then T1 dot start and T2 dot start. So what is the current thread name? T1 name is thread 0 and T2 name is thread 1. Next, join. What is the join method in thread? Public class join extends thread. Inside the public void run. For int I assigned to 1, I less than or equal to 5, I plus plus. I'm defining one try catch block. Inside the try block, I am using the sleep method, thread.sleep of 500. Inside the catch block, I am catching the exception. So always the control starts from the main method. I'm creating three objects for this class join. And first I'm invoking the start method t1.start. Then inside try, I'm again saying t1.join. So if this throws any exception, that is caught by this catch block. Then t2.start and t3.start. So we'll see the output of this program. So what is the output of program? 1, 2, 3, 4, 5. Okay. So first the thread started to run and it printed up to 1, 2, 3, 4, 5. And next we said t1 dot join. It will make the thread 1 to die and then t2 will start. So we have given here thread dot sleep of 500. So once T2 is started printing 1, again T3 will print 1. And again when T2 printed 2, T3 will print 2. And again when T2 printed 3, T3 will print 3. And this is because of the sleep method. Next is the demon thread. What is demon thread? Public class demon thread extends thread. Inside that public void run, if thread dot current thread dot is demon. Okay, sorry, I didn't discuss about demon, so I'll explain this later. Okay, I'll conclude here and I'll continue in the next topic. Okay, thank you. Hello everybody, today I'm going to discuss about thread priority. Now what is the priority of a thread? Each thread is having a separate priority. What does this thread scheduler do? The thread scheduler will schedule the threads according to some given priority. And priorities are represented between 1 and 10. And in the thread priority, three constants are defined in the thread class, that is public static int min priority, public static int norm priority, public static int max priority. And the default priority of the thread is 5 and the minimum priority value is 1 and the value of max priority is 10. Now daemon thread. What is this daemon thread in Java? Daemon thread is a service provider that is used to service the user threads. And when all the user threads die, the JVM automatically terminates this daemon thread. That is, there are many like Java daemon threads usually run at the background and they run automatically. And examples of these daemon threads are GC and Finalizer, etc. And daemon threads provide services to the user threads for background supporting tasks. It is a very low priority thread. What is thread pool? Java thread pool is nothing but it represents the group of threads working and waiting for a particular task, and they can be these threads can be reused many times. And in case of thread pool, a group of fixed size of threads are created. And first of all, what happens? A thread from the given thread pool is pulled out, and it is assigned a job by the service provider, and after the completion of the job it is again kept back into the pool. The thread is again kept back into the thread pool again. This is because due to this the better performance. The performance is good and it saves time because there is no need to create a new thread in Java. What is a thread group? Thread group is nothing but it is a group of multiple threads in a single object. That is why what is the use of this thread group? Thread group is used because we can suspend, resume, or even interrupt some group of threads by a single method call. And this Java thread group is implemented by java.lang.threadgroup class. Now, what is the shutdown hook? Shutdown hook can be used to perform some cleanup processing or save the state when the JVM shuts down normally or abruptly. What is this garbage collection? Garbage collection means that is nothing but unreferenced objects, that is, the objects which are not referred anymore. Garbage collection is a process of reclaiming the, it is nothing but reusing the reusing the memory once again automatically. In other words, this garbage collection is used to destroy the unused objects. That is, for example, in C language, free method is used for garbage collection, and in C++ we use delete method, but in Java there is no such method because garbage collection is done automatically. So the advantage of this is it provides better memory management. So Java makes memory efficient because of this garbage collector. It removes the unreferenced objects from the heap memory. What is finalize and the GC method are the garbage collection methods. Finalize method is invoked before the object is garbage collected. This method can be used for cleanup processing. GC method is used to invoke during the garbage collection to perform cleanup processing. I'll show you some examples. First is the daemon thread. Now, what is the daemon thread? Daemon thread is the service provider which is run at the background of the threads. That is, it is used to service the user threads. So, public class daemon thread extends thread public void run begin. If current thread is daemon, then I am printing system.out.println is daemon thread work. Else, I am printing user thread. So first control starts from the main method. First I am creating three objects for this daemon thread T1, T2 and T3. I am invoking this method setDaemon T1.setDaemon to true so that T1 will become the daemon thread. If setDaemon is true, then T1 will become the daemon thread. Then T1.start, T2.start and T3.start. When I say T1.start, the control goes into this run method and it will check whether the current thread is daemon or the user thread. We will see the output of this program. So first, as I said, T1.setDaemon is true. The first thread, when I say T1.start, the control goes into run method and it will check whether T1 is a daemon thread or a user thread. So T1 is daemon thread, so the daemon thread work is printed first. Then when I say T2.start, since the daemon thread is not set to true, it will go into this run method and it will print user thread work since it is not a daemon thread. And again when I say T3.start, the control goes into run method and it will check whether it is daemon or user thread. And since it is also not a daemon thread, then the statement is printed. Next, thread priority. What is thread priority? Public class thread priority extends thread. This thread scheduler will schedule the threads according to the priority given. There are three types of priority: min priority, norm priority, max priority. The default value of thread priority is 5. Minimum priority is 1 and maximum priority is 10. So inside the run method, I am printing system.out.println running thread name is thread.current_thread.getName. Then system.out.println running thread priority is thread.current_thread.getPriority. For first always control starts from the main method. I had created two objects for this class thread priority m1 and m2. When I say m1 dot set priority thread dot main priority, then it will set the priority for m1 thread, and m2 dot set priority thread dot max priority. Then when I say m1 dot start, control goes into run method, and it will print the running thread name is it will print the current thread name, and it will also print the current priority, its priority. When I say m2 dot start, control goes into run, and it will print its name and its priority. So we'll see what are the priorities for m1 and m2. So see the output here. Running thread name is first the thread 1 is the running thread name, and its priority is 10. And M2 is the next M2 is the M2 thread name is 0 and its priority is 1. Next thread pool. What is a thread pool? In thread pool, first public class thread pool implements the runnable private string message public thread pool string yes. This dot message is assigned to us. Then public void run method system.out.println thread dot current thread dot get name. Then process message. Then system.out.println thread dot current thread dot get name. Then private void process message begin try thread dot sleep of 2000. Here I'm using the try catch block inside the process message. So we'll run this program and see. I think there is a mistake in this program. Next is the thread group. This thread group, public class thread group implements runnable. Then inside that I'm defining one run method, public void run. Then system.out.println thread.current thread.get name. Then inside the main method, always the control starts from the main method. First I am creating an object for this thread group. Thread group runnable equal to new thread group. And thread group tg1 is equal to new thread group of parent thread group. Then thread t1 equal to new thread of tg1 comma runnable comma 1. So when I create an object for this thread t1 and when I say t1 dot start, the control goes into this run method and it will print the current name of the current thread. So we'll see the output of this program. See here, the first thread name is 1 and the second thread name is 2, and third one here the output is 1 2 and the thread group name. Thread group name is parent thread group. Then next the third thread is 3. This is the output of this program. Next, what is interrupt thread? Public class interrupt thread extends thread public void run try begin thread dot sleep of 1000 system.out.println task. Here I am taking a try catch block here. Inside the main method, always control starts from the main method. Once I create an object for interrupt thread t1 equal to new interrupt thread and I say t1 dot starts, the control enters into run method and it will print the output as task. And once I say t1 dot interrupt, the first thread t1 is interrupted for some time. So we'll see the output of this program. So when I say T1 dot interrupt, then an exception is handled by this program. That is, exception handled is sleep interrupted. So this is about the thread. So I conclude here. We'll continue in the next topic. Thank you. Hello everybody. Today I'm going to discuss about synchronization. Synchronization is a process which is used to achieve the control the access of all the multiple threads. Synchronization is used to achieve the control of all the or multiple threads. And Java synchronization is a better option when they want only one thread to access the shared resource. That is, there are two types of synchronization: process synchronization and thread synchronization. And thread synchronization is again of two types: mutual exclusive and cooperation. The thread communication in Java. And this mutual exclusive is of three types: synchronized method, synchronized block, and static synchronization. And we'll see what are these one by one. What is synchronized method? That is, if you declare any method as synchronized, then it is said to be synchronized method. And what does this synchronized method do? It is used to acquire lock on any particular object. That is, if, for example, if you say that a method, if you define a method as synchronized, then a thread will get access to that only particular method. It will not get access to the other methods. That is, if you say a method as synchronized, then a particular thread can access only that particular method. A thread cannot access the other methods, or a thread cannot perform operations on the other methods. That is, when a thread invokes a synchronized method, it automatically acquires a lock on that particular object and releases when the thread completes its task. Now, what is synchronized block? A synchronized block can be used to perform synchronization on any specific resource of the method. So, for example, if you have 50 lines of code and you want to access only 5 lines of code, then you can use synchronized block. The synchronized block will work same as the synchronized method. That is, synchronized block is also used to acquire a lock on an object. What is static synchronization? If you make any static method as synchronized, it is said to be static synchronization. And the lock will be acquired on the class level but not on the object. Next is the deadlock. Now, what is deadlock in Java? Deadlock in Java is a situation where the thread is waiting for a particular object lock, and that is acquired by another thread, and the second thread is waiting for an object lock that is acquired by the first thread. That is the both the threads are looking to thinking of acquiring a lock on the same object. This process is known as deadlock. If both the threads acquire a lock are thinking to acquire a lock on the same object, then this process is known as deadlock. That is, since both the threads are waiting for each other to release the lock, this condition is called deadlock. What is inter-thread communication? Inter-thread communication is allowing the synchronized threads to communicate with each other. There are three types of inter-thread communication: wait method, notify method, and notify all method. Now, what is wait method? Wait method is a predefined method used to keep the thread in the waiting state, but it does not come back to the running state automatically. That is, it must be intimated by another thread using the notify method. Now, what is notify method? Notify method is a predefined method used to intimate to a single thread to change from wait state to the running state. And notify all method is a predefined method used to intimate all the threads to change from waiting state to the running state. Now, what is an interrupt in a thread? If any thread is sleeping or waiting, then calling the interrupt method will break the sleeping or the waiting state by throwing an interrupt exception. If the thread is not in the sleeping or waiting state, then calling the interrupt method will does not interrupt the thread, but it sets the interrupt flag to true. show you some examples. What is the synchronized block? Synchronized block is nothing but I have taken one class template. Inside that void print table of int n, then begin synchronized this. Inside that one for loop int I assigned 1, I less than or equal to 5, I plus plus. Then I am printing system.out.println n into I. Then I am using a try catch block here. So I am defining one more class, my thread 10 extends thread. I'm creating an object for this parent class template t. Then I'm defining one constructor, my thread 10. So what happens? First, always the control starts from the main method. First, an object of template parent class is created here. Only one object is created, and my thread 10 t1 equal to new my thread 10 of object. So once this t1 object is created, the control enters into the constructor my thread 10, and here this dot t is assigned to t. Then next my thread 11 t2 is equal to new my thread 11 of object. When I say t1 dot start, the control enters into the run method. So we'll see the output of this program. So see here, the output is first IA is 1, then n into I is printed here. What is the value of n? The value of n is, when I say t1 dot start, first the control enters into the run method, and the value of 5 is replaced in this print table, and then n into I is printed. First I value is 1, so 5 into 1 is 5, 5 is printed. Then I value is 2, 5 into 2, 10, 5 into 3, 5 into 4, up to 5 into 5. Then the thread goes into sleep state. Once the thread goes into sleep state, then again I am saying t2 dot start. So once I say t2 dot start, the control enters into this run method of my thread 11. The value of n100 is replaced here. Then 100 into 100, 100 into 2, 200, up to 500 is printed here. So this is the output of the program. This is a synchronized block. That is, the operation is performed. This particular operation is performed. This is a synchronized block. Next, synchronized thread. What is a synchronized thread here? Class table, synchronized void print table of intent. This is known as synchronized method. So this the lock is acquired on this particular method. Again, the control starts from the main method. So when the object of the table, only one object is created here. Then my thread 1 t1 equal to my thread of object. So what happens when I run this program? Here also same, when I say t1 dot start, the control enters into the run method of this my thread 1. So here n value is 5, is replaced in this n, and 5 into 1, 5, 5 into 2, 10, 5 into 3, 15, 5 into 4, 20, 5 into 5, 25 is printed. Then when T2, when I say T2 dot starts, the control enters into my thread run method of this my thread 2, and end value 100 is replaced here. Then 100 into 1, 100, 100 into 2, 200, 100 into 3, 300, 100 into 4, 400, 100 into 5, 500 is printed here. This is the synchronized thread. Then inter-thread communication. What do you mean by inter-thread communication? It is the threads can communicate with each other. Class customer, int amount is assigned to 10,000. Then this is a synchronized method here. Then this is also a synchronized method. First the control enters into main method. We say final customer c equal to new customer. Then new thread public void run c dot withdraw 15,000 dot start. So first when I say dot start, the control enters into this run method, and it replaces it invokes the withdraw method with this object c. Then inside the withdraw method, the amount is replaced with 15,000. So it goes into the withdraw method of this. The amount is replaced with 15,000. Then going to withdraw is printed here. And if this amount is less than this dot amount is less than 10,000, then this will be printed. Otherwise, it will wait for some time. So we'll see the output here. First going to withdraw is printed, and since 10,000 is less than 15,000, less balance waiting for deposit is printed here. Then again, when I say this public void run dot start, that the control deposit is invoked using the C object. And the amount is 10,000 is replaced here. Then it says going to deposit. And this dot amount is assigned to this dot amount plus amount. That is 10,000 is added with 20,000, then 20,000. Then withdraw. Then withdraw completed will be printed here. Why? Because if 20,000 is not less than amount, so thread will wait for some time, and it is decremented. The amount is decremented here. Then withdraw completed will be printed here. So I'll conclude here and continue in the next class. Thank you. Hello everybody. Today I'm going to discuss about Java input output. Java input output is used to process the input and get the output. This is a concept of files. Here we will study the concept of file handling in Java, the Java input output. That is, the Java uses the concept of stream to make the I/O operations fast. It is having a library package called java.io package, which contains all the classes required for input and output operations. Now, what is a stream? Stream is a sequence of data. The stream consists of bytes of data, and it is called a stream because it is similar to a stream of water flow. Output stream. Java application uses an output stream to write data to a destination. It can be a file, an array, a peripheral device, or a socket, etc. Input stream. Java application uses input stream to read data from a source, and it may be also a file, an array, peripheral device, or socket. First, we'll see what are the types of file I/O. First one is the file output stream. Java file output stream is an output stream used for writing the data to a file. So file output stream is used for writing the data to a file. Only data, we can write only data to a file. If you have to write primitive values into a file, you need to create an object for file output stream class first. And you can also write byte oriented as well as character-oriented data through file output stream class. But if you want to write only character-oriented data, then it is preferred to use file writer class instead of file output stream. Next one is the file input stream. Java file input stream class is used to write the input bytes, is used to obtains input bytes from a file. That is, it is used for reading the byte-oriented data. Byte-oriented data is nothing but stream of data, such as such as images, audio, video, etc. And you can also read the character stream data. But for reading character streams, it is better to use file reader instead of file input stream. And next is the buffered output stream. Buffered output stream is nothing but it is used to improve or increase the execution speed. And Java buffered output stream class is used for buffering an output stream. So due to this buffering, it will improve or increase the execution speed. That is, it internally uses buffer to store the data. So it makes the performance fast. Next, buffered input stream is also used to read information from the stream. It also internally uses buffer mechanism to make the performance fast. That is, it is used to improve or increase the execution speed. And this buffered input stream is containing all the data of the file in the form of multiple buffers. That is, when buffered input stream is created, an internal buffer array is created. Next is a sequence input stream. Java sequence input stream class is used to read data from multiple streams. That is, when you consider buffers input stream and buffer output stream, buffered input stream is used to read data from a single stream, whereas sequence input stream is used to read data from multiple streams. That is, it reads the data sequentially one by one. Next is the byte array output stream. Java byte array output stream is used to write the common data into multiple files. In this stream, the data is written in the form of byte array, which can be written into streams later. That is, first it is written into byte array, then it is forwards to multiple streams later. And byte array output stream is used to byte array output stream is used to write the data into the buffer. Before writing the data, it is mandatory to create an object for byte array output stream. Next, byte array input stream. Byte array input stream is also, as the name suggests, that is byte array in input stream. First, it can be used to read the byte array as an input stream. This byte array input stream class contains internal buffer which is used to read byte array as a stream. That is, data is read from a byte array. So we'll see some examples here. First is the file output stream, public class file output stream. Again, public static void main string args. Always the control starts from the main method. First, the object for this class file output stream object is created. That is, in order to write the data into a file output stream, first you need to create an object for the file output stream. File output stream f equal to new file output stream of, give the path here where you want to write into a file, and f_write of 65. There is a write method here in the file output stream. Using this object f, you can invoke this write method so that it writes 65 into this file, which is represented here, testout.txt. Then after doing the operation, you can close the file and system.out contains success. So once you run this application, so success is printed here, and we'll check whether this output 65 is written into this file or not. So go to read. So see here, test out. You open this file and see the ASCII value of 65 is written here. So next is the buffered input stream. Now what is this buffered input stream? Public class buffered input stream always control starts from the main method. First, first when you want to write, when you want to use the buffered input stream, when you want to read data from the buffered input stream, you need to create an object for the file input stream. That is file input stream f input equal to new file input stream of read drive of text out of text, then create an object for buffered input stream. BIN equal to new buffered input stream of file input stream. Then while I equal to object of buffered input stream dot read not equal to -1. Not equal to -1 means it is not null. Then system dot out dot print character of I. So we'll see the output of this program. See actually what it does, it reads first it reads the character whatever is written, data is written into this file test out. It will read, and if it is not, it will check this condition. If it is not null, it will print the character value of this. Actually previously we had written 65 into this file, then it will print the character value here of 65. Next, buffered output stream. File output stream. First, before you need to write an object to your file, the buffered output stream. First, you need to create an object for file output stream. Then buffered output stream b out equal to new buffered output stream of f out. Then string s equal to welcome to Java t point. Then byte b array equal to s dot get bytes. B out dot write of b. What it is doing here, s dot get bytes means for this string it will get the bytes and then it will write into this file output stream. It will get the bytes using this buffered output stream and then it will write into this buffered output. It will write into this file test out.txt. So we see this output. The success is printed here and we'll see the output also. See, welcome to Java point is written here. Next, byte array input stream. What is byte array input stream? In this byte array, public class byte array input stream, as the control enters into main method, byte array buffer equal to 35, 36, 37, 38. An array is taken here because the data will be in the form of an array. The data is read in the form of an array. Then int k assigned to 0 while k equal to byte array input stream object dot read not equal to null. Then character conversion of a byte into character. These bytes are converted into character. Character change to the character of k. Then ASCII value of k. So when we run this program, the ASCII value of the character is 35. First, k equal to byte drop read. First it will read this array into this k. 35 is taken into k and it is not equal to null. Then it will convert this byte 35 into character. So ASCII value of 35, ASCII value of the character is 35 and its special character is hash. Similarly, ASCII value of character 36, special character is dollar. Similarly, ASCII value of character is 37, special character is percentile. ASCII value of character is 38, special character is ampersand. So this is byte array input stream. Next is byte array output stream. Here also control enters into the main method. First the file output stream object is created. In the D drive, two files, here the path should be taken inside the file output stream. And then an object is created for byte array output stream. Then using this object I am writing 65 into this file fout1 and fout2. So when I run this program, so success is printed here. And if you open the D drive, see F1 and F2 both 65. The ASCII character value, ASCII value 65 is written here in F1 as well as F2. So I will continue in the next class. I will conclude here. Thank you. Hello everybody. Today I am going to explain about collections. Now, what is a collection? What are collections? Collection is a framework, and collections are used to store the data and manipulate the group of objects also. Okay, collection is used to store objects and also manipulate these objects. And these Java collections can perform various operations like insertions, deletions, searching, sorting, manipulation, etc. And Java collection is nothing but a group of objects. And collection framework provides many interfaces like list interface, set interface, map interface, queue, PQ, etc. And these interfaces are implemented by the classes like array list, linked list, vector, stack, hash set, linked hash set, tree set, etc. And collection is nothing but, for example, when you consider uh, an array, an array can only contain the data. An array can hold only data one or more elements of similar data types. If you consider an array can hold only one or more elements of similar data types. So an array cannot hold more than one object of different classes. So in Java, this can be achieved using a special concept called collection frameworks. Okay, so collection, the user-defined data type holds more than one value of dissimilar data types, and class is an example of user-defined data types. So collections are known as user-defined data types. Collections are nothing but collections are the user-defined data types which holds more than one value of dissimilar data type, and class is an example of user-defined data type. And for every collection object, a predefined class is available, which is known as collection class or a container class. And all the predefined collection classes are available in a package called java.util package, where util represents the utility package. And these collection of predefined collection classes or container classes are known as collection framework. And if you consider the differences between array and collection, array is a collection of homogeneous objects or similar objects. Whereas collection object is nothing but it is a collection of different objects, that is heterogeneous objects. And array is having a fixed data, fixed size, whereas collection is having a dynamic or varying size. And array can add any object at the we can add any object at the end of the array, but it is not possible to insert an object in the middle of the array. In the collection of whereas in the collection object we can add the objects in array. That is, it supports addition, insertion, deletion, etc. And, so, what are the interfaces we are having in Java.util package? Interfaces are list, set, map, queue, etc. And there are classes like array list, linked list, hash set, linked hash set. Okay, these are the classes which implements these interfaces. So first we see what is an array list. An array list is nothing but it implements the list interface. Array list implements the list interface and it uses a dynamic array to store the duplicate elements of different data types. And the array list maintains the insertion order. Maintaining the insertion order means in whatever order you give the input, you get output in the same order. And array list is non-synchronized. Non-synchronized means it is not thread safe. That is, not thread safe means multiple threads can access simultaneously. And the elements stored in the array list can be randomly accessed. So array list is similar to a array, but array list is a growable. It is said to be a growable array. That is, any number of elements can be inserted or deleted from the array list. Next is the linked list. Linked list implements the collection interface and it uses a doubly linked list internally to store the elements. And linked list can store duplicate elements also. Linked list also maintains the insertion order and it is not synchronized. Not synchronized means not thread safe. That is, multiple threads can access simultaneously. In the linked list, the manipulation is fast. Next is vector. What is vector? Vector is similar to array list, which is also a growable array. That is, the elements can be added or inserted or removed at any position. And but vector is synchronized. What is the difference between array list and vector? Array list is non-synchronized, that is not thread safe, and vector is synchronized, that is thread safe. Thread safe means only one thread can access at a time. Now next is the stack. What is a stack? Stack is a subclass of vector, and the elements in the stack the stack is a predefined class which can store a list of elements in the last and first out order. Next is the set interface. What is the set interface? The set interface in Java is present in java.util package. It extends the collection interface and set represents the unordered set of elements. Unordered set of elements means set does not maintain the insertion order. That is, in whichever order you give the input, you will not get the output in the same order. You will get in a different order. And set does not allow us to store the duplicate elements. And we can store at least one null value in the set. Set is implemented by hash set, linked hash set, and trace set. Now, what is hash set? Hash set implements the set interface, and hash set represents the collection that uses the hash table for storage. Hash set also contains unique items. It does not allow duplicate values. Next is linked hash set. What is linked hash set? Linked hash set represents the linked list implementation of set interface. Linked hash set extends the hash set class and implements the set interface. And like hash set, linked hash set also contains unique elements. That is, it does not allow duplicate elements. Linked hash set also maintains the insertion order and permits the null elements. Next is sorted set interface. Sorted set interface is the alternate of set interface that provides a total ordering on its elements. That is, in the sorted set interface, the elements are in order. That is, the elements of sorted set are arranged in the increasing or ascending order. Next is tree set. Java tree set also implements the set interface that uses a tree for storage. Like HashSet tree set also contains the unique elements. Unique elements means it does not allow duplicate elements. And the elements in the tree set are stored in ascending order. Next is list. What is a list actually? List is an interface and it is a predefined interface in java.util package and is similar to the set interface, but the list allows duplicate values and the elements can be added in both forward and reverse direction in the list. Whereas if you consider a set interface, elements can be added only in the forward direction. And list contains index-based methods to insert, update, delete, and search the elements. And it list can also contain the duplicate elements, and we can also store the null elements in the list. And through the list iterator interface, we can iterate the list in forward and backward directions. And what are the implementation classes of the list interface? Implementation classes are array list, linked list, stack, and vector. Next is Java list iterator interface. List iterator interface is used to traverse the element in backward and forward direction. Actually, retrieving elements from the collection object, that is, the elements can be retrieved from collection object in four ways. First is using for each loop, second is the iterator interface, third is the list iterator interface, and fourth is the enumerator. And for each loop can be used to retrieve each and every element from the collection object. It is similar to the for loop, where the for each loop will be executed multiple times based on the elements of the collection object. Next is second one is the iterator interface. Iterator interface is a predefined interface in Java.util package, which can be used to retrieve elements of the collection object only in the forward direction. Okay, and third one is the list iterator interface. List iterator interface is also similar to iterator interface, what can be used to retrieve the elements from the collection object in both forward and reverse direction. And the last one and fourth one is the enumerator interface. Enumerator interface is similar to iterator interface, but the elements can be retrieved only in the forward direction and it does not have a remove method. Enumerator interface does not have a remove method, that is, elements cannot be removed using enumerator interface. Okay, we'll see some examples now. First, we'll see the array list. See here, first we need to import the java.util package, util.star, and public class array list begin inside the main method. First, the control always starts from the main method. First, we are creating an object for the array list. Array list equal to new array list. Why we can create an object for array list? Because array list is a class. It is not an interface. So we can create an object for array list. Then using this object of array list, I'm invoking the add. I'm calling the add method. This array list contains add method. So I'm adding these objects into the array list. What are the objects? List.add Ravi, list.add Vijay, list.add Ravi, list.add Ajay. Then traversing the list through iterator. Now how I am traversing this list, array list? I'm traversing this array list through iterator interface. Since iterator is an interface, we cannot create an object for an iterator. Just we need to create an instance. That is, iterator itr is equal to array list object list.iterator. While itr.hasNext. This iterator has a method known as hasNext. That is, it is checking whether this array list is containing any element or not. If array list has any elements, then it will system.out.println, it will print the next element. I will run this program, we'll see what is the output. So the elements are displayed here: Ravi, Vijay, Ravi, and Ajay. Okay. So next is the array list, array arrange. We'll see how array can be retrieved. Okay, this is not. Next, we'll see linked list. What is a linked list? First, we need to import java.util package, public class linked list. Always the control starts from the main method, linked list. Since linked list is also a class, we can create an object for the linked list. Linked list al equal to new linked list. And this linked list contains to add the elements. What is the method for linked list? What is the method used for linked list? Add method. So al dot add, I'm adding the objects to the linked list Ravi, al dot add Vijay, al dot add Ravi, al dot Ajay. Then I'm traversing this linked list using the iterator interface. Since iterator is an interface, we cannot create an object for iterator, just we can create the instance iterator itr equal to al dot iterator. Then the iterator will check whether the linked list is containing the next element or not using has next. If any next element is there, it will print the next element. Then we'll see the output here. Same, the items are displayed here: Ravi, Vijay, Ravi, and Ajay. Since the linked list allows duplicate elements, here Ravi is printed 2 times because linked list allows the duplicate elements. Next is the array list linked list. Next is the list iterator. Import java.util.start public class list iterator. Always control starts from the main method. Since list is an interface, we cannot create an object for the list. Just we need to create an instance for this list. List al equal to new array list. The object is created for the array list. Then we have some methods in the list interface, that is add method is there. So al dot add Amit, al dot add Vijay, al dot add Kumar, al dot add 1 comma Sachin. Then list it, since list iterator is an interface, we cannot create object for list iterator. Just we create an instance itr is equal to al dot list iterator. Then system dot out dot println traversing elements in the forward direction. Now what is list iterator? List iterator is used to traverse elements in both forward and backward direction. Okay, and so it will check, the list iterator checks whether this list is having any next element or not. While itr dot has next, then system dot out dot println index plus itr dot next index plus value plus itr dot next. Next index is used to give the index value, and next is used to give the value, next value. Then system dot out dot println traversing elements in the backward direction. That is, it will check whether a list is having any previous element. Using this itr dot has previous. If it has a previous element, then system dot out dot println index plus itr dot previous index plus value plus itr dot previous. Then we will run this program. So see here, first the index value is 2 and value is Vijay. Index value is 2, value is Vijay, then index value is 3, value is Kumar. Then forward direction, that is elements are traversed in the forward. Sorry, 1 minute. So traversing elements in the forward direction, index 0 value is Amit, index 1 value is Vijay. Sorry, value is Sachin at index 1. See here, al dot add, that is list can be used to add the elements anywhere. You can add the elements anywhere in the list. So at index 1 value is Sachin here. Then at index 2 value is Vijay, at index 3 value is Kumar. Then traversing the elements in the backward direction. When you traverse the elements in the backward direction, first the index 3 value is Kumar, index 2 value is Vijay, index 1 value is Sachin, and index 0 value is Amit. This is list iterator. The next we will see what is has set. import java.util.star public class hasset. Always control starts from the main method. Since hasset is a class, we can create an object for the hasset. Hasset set equal to new hasset. Then this asset is having how to add elements in the asset using the add method. So set dot add of Ravi, set dot add of Vijay, set dot add of Ravi, set dot add of Ajay. Then how to traverse the elements of the asset using iterator interface. Since iterator is an interface, the instance is created here itr equal to set dot iterator, and it is checking whether this asset is having any next element using has next. And if it is having a next element, then it is printing the next element. See here, the Ravi set does not allow the duplicate values. That is why Ravi is printed only once. Okay, Vijay, Ravi, and Ajay. Because set does not allow duplicate elements. Hash set does not allow duplicate elements. The next is the linked hash set. So import java.util.start public class linked hash set. Always the control starts from the main method. Linked hash set equal to new linked hash set. Then since linked hasset is a class, we can create an object for linked hasset. And how to add the elements to linked hasset using add method. Set dot add Ravi, set dot add Vijay, set dot add Ravi, set dot add Ajay. Then how to traverse the elements using the iterator interface. Iterator itr equal to set dot iterator. And this is control is checking whether this linked hasset is having any next element using itr has next. If it has any next element, it will print the next element using our system.out.println itr.next. Then we'll see the output of this. See here, linked hasset also it does not allow the duplicate elements, so Ravi is printed only once. Next is the tree set. Input java.util.start public class tree set. Always control starts from the main method. Tree set is a class, so we can create an object for tree set. Set equal to new tree set. We have add method for tree set to add in the element to add the elements. Set dot add Ravi, set dot add Vijay, set dot add Ravi, set dot add Ajay. How do we traverse the elements in the tree set using iterator interface? So iterator itr equal to set dot iterator, and control is checking whether this tree set is having any next element using itr dot has next. If it has any next element, then system dot out dot println iterator dot next. See here, tree set also doesn't allow any duplicate values. So since Ravi is given twice here, it takes only once. Output gives only Ravi once. So I'll conclude here. I'll continue in the next class. Thank you. Hello everybody. Today I'm going to explain about map interface. Map is an interface. Okay, Java map interface contains values based on key value pairs. That is, map contains key and value pair, and each key and value pair is known as an entry. A map contains only unique keys, and a map is useful for operations like search, update, delete elements on the basis of a key. And map does not allow duplicate keys, but it can allow duplicate values. And hash map and linked hash map and tree map are the implementation classes for the map interface. And hash map and linked hash map allow null keys and null values both. But tree map does not allow any null key or value. First, we'll see what is a Java hash map. Java hash map class implements the map interface which allows us to store the key and value pair where keys should be unique. and it is used to perform operations using the key index like updation, deletion, etc. And this hash map class is found in java.util package. If you consider the difference between hash map and hash table, hash table is a legacy class. Legacy means it is a old type of class, uh, and whereas hash map is not synchronized and hash table is synchronized. Hash map is not synchronized, whereas hash table is synchronized. Non-synchronized means not thread safe, that is multiple threads access simultaneously. Synchronized means thread safe, that is only one thread can access at a time. So hash map allows us to store the null elements as well as null values, but there should be only one null key. And hash map inherits the abstract map class and implements the map interface. Now we'll see what is this Java linked hash map class. Java linked hash map class is a hash table and linked list implementation of the map interface and with predictable iteration order. So Java linked hash map inherits the hash map class and it implements the map interface. What is this Java tree map class? Java tree map class provides an efficient means of storing the key value pairs in the sorted order. Tree map is nothing but the elements are stored in the sorted order, that is ascending or the increasing order. Java hash table class. Java hash table class implements a hash table which maps keys to values. It inherits the dictionary class and implements the map interface. Next, we'll see what is a comparable interface. Java comparable interface is used to order the objects of the user-defined class, and this comparable interface is found in java.lang package, and this comparable interface contains only one method, that is compare to method. Comparable interface contains only one method, that is compare to method. That is, it provides the single sorting sequence only, that is, you can sort the elements on the basis of single data member only. Next is comparator interface. Comparator interface is used to order the objects of a user-defined class, and this comparator interface is found in java.util package, and this comparator interface also contains two methods, that is compare method and equals method, whereas comparable interface contains only compare to method. Comparative interface provides multiple sorting sequences, that is, you can sort the elements on the basis of any data member, for example, roll number, name, age, or anything else. So what is the difference between comparable and comparator? Comparable interface has only one method, that is compare to method, whereas comparator interface has two methods, compare method and equals method. And comparable interface provides a single sorting, that is, you can sort the elements on a single data member, the basis of single data member, whereas comparator interface provides multiple sorting sequences. That is, we can sort the elements on the basis of any data member. Vector. Now, what is a vector? Java vector is like a dynamic array and which can grow or shrink its size. So vector is similar to a array list. Vector is similar to array list, but which is also growable array. Vector is also a growable array, that is, the elements can be added, inserted, or removed at any position. Both array list and vector contains predefined methods to perform various operations on elements. But comparing to array list, vector is more efficient. And vector is serializable, that is, all types of objects can be stored in the vector, whereas array list is not serializable. So vector is more efficient compared to array list, and vector is a dynamic array, that is, the array can be growable, and it It is a vector is also a part of Java collection framework which is found in java.util package, and vector implements the list interface. And so vector is a thread safe implementation. Thread safe means vector is synchronized. So vector is a legacy class. So that is why vector is synchronized. So we'll see some examples here. So what is a hash table here? Public import java.util.star package, then public class hash table example. Always the control starts from the main method. Since hash table is a class, we can create an object for the hash table. Hash table hm equal to new hash table. Then hash table, how to insert elements into the hash table using the put method. hm dot put 100 comma Amit, hm dot put 102 comma Ravi, hm dot put 101 comma Vijay, hm dot put 103 comma Rahul. Then for map dot entry m colon hm dot entry set. That is we are using a for each loop here. So then system dot out dot println m dot get key plus m dot get value. So we'll see the output of this program. So hash table is also like hash map. Where the value data is stored in the key value pairs. Here 100 is the key and Amit is the value. So it does not preserve the insertion order. Hash table does not preserve insertion order. So insertion order means in whatever order you give the input, you will get in output in the different order. So hash table does not preserve the insertion order. So this is about hash table. Next is the map. We'll see about map interface. So this is the example for map import java.util.star public class map example. Always the control starts from the main method. Since map is an interface, we cannot create an object for interface, map interface. So just we create an instance map equal to, we can create an object for new hash map. Then this map is having the method called put to add the elements in the key value pairs. How do you add the elements inside the map using key value pairs? So map dot put 100 comma Amit, map dot put 101 comma Vijay, map dot put 102 comma Rahul. Then the elements can traverse in any order. For the map interface, elements can traverse in any order. So this is using for each loop. For map dot entry m colon map dot entry set begin, then system dot out dot println m dot get key plus m dot get value, and we'll see the output of this. See here 100 is the key value, Amit 100 is the key and Amit is the value here, 101 Vijay, 102 Rahul. This is about the map interface. Next one is the hash map. We'll see hash map example. Public import java.util.star public class hash map example. Always control starts from the main method. Since hash map is a class, we can create an object for the hash map. Hash map equal to new hash map. And how to add elements using key value pairs. Map dot put 1 comma mango, map dot put 2 comma apple, map dot put 3 comma banana, map dot put 4 comma grapes. Then system dot out dot println iterating hash map. Then for map dot entry m, how do you iterate the hash map? We can iterate hash map using for each loop also. So this is the syntax for each loop. For map dot entry m colon map dot entry set begin, the system dot out dot println m dot get key plus m dot get value. we'll see the output of this program. So how do you get the values? Iterating hash map. 1 is mango, 2 is apple, 3 is banana, 4 is grapes. That is, hash map also gives the output in the form of key value pairs. Next is the linked hash map. What is linked hash map? Public class linked hash map. Control starts from the main method. Since linked hash map is a class, we can create an object for linked hash map. Linked hash map hm equal to new linked hash map. Then hm dot put 100 comma Amit, hm dot put 101 comma Vijay, hm dot put 102 comma Rahul. Then how do you traverse the linked hash map? Using the for each loop. For map dot entry m colon hm dot entry set. That is, linked hash map is having one method called entry set here. Then system dot out dot println m dot get key plus m dot get value. Then we'll run this program. So see here, the output is in the form of key value pairs. Next we'll see vector. Now what is vector? Public class vector example. Always control starts from the main method. Since vector is a class, we can create an object for vector. Vector v equal to new vector. Then how do you add the elements into the vector? Using add method. V dot add Ayush, V dot add Amit, V dot add Ashish, V dot add Karina. Then how do you traverse the vector? Using the iterator interface. Since iterator is an interface, we cannot create an object because we can create an instance. Iterator itr equal to v dot iterator. There is a method called iterator method in the vector class. Then when it is checking whether the iterator is having any, the vector is having any next element. If it using the iterator dot has next. If it is having the next element, it will bring the next element. We'll see the output here. See, this is the output. So this is about vector. Next is comparable example. I'll show you this comparable example. Public class comparable implements comparable interface. Okay, comparable is an interface. I'm taking int roll number, string name, int age. Now, first of all, what is a comparable interface? Comparable interface is an interface which is having only one method, that is compare to. And this performs comparable interface performs sorting based on only one value, that is using either roll number or name or age. This comparable interface can perform sorting using either roll number, name or age. Only sorting can be done only based on only one value only. That is, comparable ex is a constructor here. Int roll number, string name, int age. Begin, this dot roll number is equal to roll number. This dot name is name. This dot age is age. Public int compare to. Age is equal to st dot age, return 0. Else if age is greater than st dot age, return 1, else return minus 1. Now I'm taking a main I'm taking one more class. So this is the program for comparable, and so I'll conclude here and we'll continue in the next class. Okay, thank you. Hello everybody, today I'm going to discuss about serialization and deserialization. Serialization is a mechanism of writing the state of an object into byte stream and dumping into a file, and it is mainly used into Hibernate and DJB technologies. And the reverse operation of serialization is called deserialization, where the byte stream is converted into object. And the serialization and deserialization process is platform independent. It means that you can serialize an object in one platform and deserialize in a different or other platform. And for serializing the object, that is for converting the object into byte stream, we require a write object method of object output stream. And for deserialization, that is converting the byte stream into an object, we call the read object method of object input stream class. And we must have to implement the serializable interface for serializing the object. What is a transient keyword? Transient keyword is used in serialization, and if you mention or if you define any data member as a transient, it will not be serialized. So we'll see some examples for this. First, serialization. First, I'm taking one student class. Before that, we need to import java.io.serializable. Then public class student implement serializable. I'm taking two data members here, int id and string name. Taking one constructor student. Inside that, arguments are int id and string name. Then this dot id equal to id, this dot name equal to name. Then how do you perform serialization? First import java.io.start, then public class serialization example. Always the control starts from the main method. Here inside the I'm taking try catch block, and inside try I'm creating an object for the student class. That is student s1 equal to new student of 211 comma Ravi. Once the object of the student is created, the control goes into this student class and this constructor is invoked, and the values are replaced with the id and the name. That is, the values for id and name are 211 and Ravi. Then now we need to create a stream and then write the object. So what is serialization? We need to convert an object into byte stream. In order to convert an object into byte stream, we need to create a stream and then write the object and dump into a file. Then file output stream fout equal to new file output stream of here I mentioned one directory like this. File output stream of d drive dot text. Then object output stream out equal to new object output stream of fout. Then how do you write the object using write object method? Out dot write object of s1 and out dot flush. Then how do you close the stream? Out dot close. So we run this program. Then once we run this program, okay, sorry. You get success. That is what is happening here. This data 211 and Ravi, that is ID and name, are converted into byte stream and returned and dumped into this file in the D drive, that is f.text. So we'll check the D directory in the f.text whether it is dumped into the file or not. So we'll run it once again. So we'll run it once again. Run as Java application. So our output is success. So we'll check the D directory whether it is dumped into our file or not. I think there is some mistake here. Okay, it is actually the object is converted into byte stream. So that is the output we see there. Next, what is deserialization? Deserialization is nothing but always the control starts from the main method. First, we need to create a string to read the object. That is object input stream in equal to new object input stream of new file input stream of dot text. Here also I will give one directory here. Then student is equal to student of in dot read object. That is we require a read object here to read the data from the file and convert it into object. Then printing the data of the serialized object system.out.println s.id plus s.name. Then closing the string. Check the output of this. So the output that is from this file, if this is the in the byte stream. This is in the form of byte stream. So that output again from the file is converted to object and is displayed here. This is about serialization and deserialization. Now, what is transient keyword? For transient keyword, first we import java.io.serializable, then public plus transient ex implement serializable. I am taking two data members here, int id and string name, and one more data member I am defining it as transient, int age, so that this age will not be serialized. In public transient example, int id, string name, int age. Then this dot id is assigned to id, this dot name is assigned to name, this dot age is assigned to age. Now, what is this transient? How do you perform serialization now? Public class persist ex, and always control starts from the main method. Transient ex s1 equal to new transient of 211 comma Ravi comma 22. Once the object is created for this, the control enters into this transient and the values are replaced for this id, name and age. It is the values of 211 is id, Ravi is name and age is 22. Then we need to write an object into file that for that one file output stream f equal to new file output stream of, here I'll take one more file. I'll take one file.text. Then object output stream out equal to new object output stream of f. Then we need a write object method here to write object to byte stream into a file, that is out.write object of s1, then out.flush. Then we run this program. So output is success. Now we'll check the D directory whether it is written into D drive or not. So this is in the form of bytes. So it is successfully written. That is age is not since age is transient. Here only name Ravi and ID and the name Ravi has taken, but age is not given here because age is serialized. So I'll conclude here. We'll continue in the next class. Thank you. Hello everybody. Today I am going to discuss about AWT. Here AWT stands for Abstract Window Toolkit. In Java language, AWT can be used to design GUI based applications. What is GUI? GUI means graphical user interface. So AWT can be used to design GUI based applications. And to design GUI based applications, Java provides some predefined classes in its library. Okay. That is where does it provide these classes? It provides in the form of java.awt.star package. So to create different components like label names, text boxes, text area, button, AWT package provides some predefined classes, and each and every predefined class is located in java.awt package, and these represent an AWT component. That is, each of these classes like label names, text boxes, text area, button, etc. All these are all these represent the AWT components, and they are resided in the java.awt package. In Java language, mainly two types of packages are available to develop 100% efficient GUI based applications. So there are two types of packages available in this AWT. One is java.awt.star and the other one is java.awt.event.star. And this java.awt.star mainly contains predefined classes like label, text boxes, text area, text field, button, etc. used to develop the AWT components but cannot be used to give functionalities for AWT components. That is the components which are present in java.awt.star, that is the label, text field, text boxes, text area, and button, etc. Are just they are known as the AWT components, but they cannot provide any functionalities. That is, a static page can be developed with all these components. The next, that is, even if you click a submit button, no operation will be performed because there is no functionality given in this GUI component because they are static. Since they are static, there will be no functionality given to this GUI components. And how this functionality is possible? This functionality can be possible only by using event handler. Now, what is this java.awt.event.star? This package contains predefined classes used to provide the functionalities for the GUI components. That is, when you click a submit button, some operation will be performed. The predefined classes of this package can be used to achieve event handling. That is, and whenever we want to create any AWT component, first we need to create an object for that class. Now, what are the types of AWT components? In Java language, components are mainly classified into auxiliary components and logical components. Auxiliary components are the components which are having both the touch and field. That is, no predefined classes are available for the auxiliary components in Java language, whereas logical components are the components which are having only field. And these are mainly classified into passive components and active components. And examples of active components is keyboard and mouse. That is, they are having only the uh, okay, passive and active components. So examples of active components is keyboard and mouse. And passive components does not have any integration with the user. That is, they do not have any interaction with the user either by mouse or the mouse and the keyboard. That is, label names like name, username, password, etc. These are the passive components. That is, these passive components are mainly used to identify the input fields. But that is, the label names are mainly used to identify the input fields, but no operation can be performed on that. Whereas active components can interact with the user. That is, text box, text area, radio button, checkbox, button, etc. are the active components. Next, That is java.lang.object is the predefined base class for any Java program, either for predefined or user-defined classes. That is java.awt component is predefined class and it is the base class for each and every AWT component class. Next, what is a container? Container is a predefined class in AWT package used to integrate all the components. That is into a single unit. That is container contains all the components. It is used to integrate all the components into a single unit. Next, what is a window? Window is a predefined class in the AWT package which will act as a container while developing the GUI applications. Window also acts like a container, and we must create an object class. We must create an object class at the time of development of GUI application only. Next is frame. What is frame? Frame is a Frame is a predefined class in AWT package which represents a blank space in the window. That is, frame also represents a window, but what is the difference between frame and window? Frame represents a blank space in the window, and it is very mandatory to use at the time of development of GUI applications. Next, next is the that is, components of AWT can be arranged in any order within the container based on the requirement of the user. But how these components are arranged in the container, this is not possible directly. It can be achieved only by using some special layouts. How the components can be arranged in the container. Components cannot be arranged directly in the container. They need some special layouts. Now, what are these layouts? Layout is a plan which can be used by any user to arrange the components in a systematic order in the window. And Java supports four types of layouts. There are four types of layouts. What are those? Border layout, flow layout, grid layout, and grid bag layout. And these four are the predefined classes in the AWT package. What is a border layout? The border layout mainly contains five different parts. That is, whenever object for border layout is created, the container is divided into five parts. What are these five parts? The center is the default location for border layout, and the other four parts are north, south, east, and west. And border layout is the default layout for the frame class. Next is the flow layout. What is a flow layout? In the flow layout, we can arrange all the components in a sequential order. Okay, what is a flow layout? Where we can arrange the components like labels, text boxes, and everything in a sequential order. Next, grid layout. What is grid layout? Grid layout is used to arrange all the components in the rows and column format. That is in the form of cells. And but in the grid layout, there is no space formed between the cells. What is grid bag layout? Grid bag layout is used to arrange all the components in the rows and column format. But the difference between grid and grid bag layout is that grid layout does not contain any spaces, whereas grid bag layout contains spaces between the cells. Next, we'll discuss about frame. Frame is a predefined class in the AWT package which represents a blank space in the window. Just now I had told you frame represents only a blank space in the window. That is, whenever we are creating object for the frame class, that will be internally prepare the window as well as the container. Next is the and another non-container classes are whenever we want to create any GUI component inside the frame, that related object should be created first. That is, whenever you want to create any component like label, text field, text area, button, etc. inside the frame, that first that related object should be created first, and finally that object can be added to the frame. Now, what is a label? Label names are the identifiers in the GUI applications. Like what are the label names you are having? Name, email ID, age, etc. how the label object is created, label L equal to new label of label name. Next is button. Button is a predefined class used to create buttons. Checkbox. What is a checkbox? Checkbox can be used either for single or multiple selection of items which are available on frame. What is a checkbox? Checkbox is used to select either single or multiple selections of items. And single selection, how it is achieved? Single selection can be achieved by creating radio buttons. To create radio buttons, we should create an object of checkbox group class, and that should be passed as reference in the checkbox class object. Next is the text field. What is a text field? Text field is a predefined class used to create the text box. So all of you know what is a text box. So text box allows all types of data like alphabets, numerics, special symbols, etc. So these are the predefined classes available in the AWT package. Next is the text area. Text area can be used to create a text area. Allows more data in rows and columns format. That is, sometimes you need to add more lines. Then you need a text area in the form of rows and columns. So I told event handling. What is an event handling? That is changing the state of an object is known as event. And for example, clicking a button, dragging a mouse, etc. And this java.awt.event package provides many event classes and listener interfaces for event handling. So now I'll show you some examples. First, see this AWT example. First, import java.awt.star. Then public class AWT example extends frame. Then constructor is taken here AWT ex. Then first object for the button is created. Button B equal to new button of button name. Then B dot set bounds of 30, 100, 80, 30. What do you mean by this? We are setting the position of the button or setting the button position. Then add of B. That is adding, we are adding the button to the frame. Then set size of 300, 300. What is this set size? Set size is the frame size of width 300 and height 300. Then set layout of null. Set layout null means we are not using any layout here. There is no layout manager. Then set visible true means now frame will be visible. By default frame is not visible. So if you say set visible true, then frame will be visible. So now we will run this program. So this is the window, and sorry, this is the frame. Inside the window there will be the frame, and inside the frame we have created a button, but if you click the button nothing happens here, no functionality is taking place. Why? Because this is static now. There is no functionality in the AWT java.awt.star package. Only functionalities can take place in java.awt.event package. Okay. Next is the button example. Here public static always first import java.awt.star public class button example. Always control starts from the main method. First we are creating the object for the frame here. Frame f equal to new frame. Here it is the frame name. Then final text field object df equal to new text field. Now we are creating a text field object here. Then we are setting the position of the text field. How do you set the position of the text field? By using tf dot set bounds of 50, 50, 150, 20. Then button b equal to new button of click here. This is the button name. And then we are setting the position of the button by b dot set bounds of 50, 100, 60, 30. Then b dot add action listener of new action listener. Now event handling is taking place now. Public void action performed is the method here. Tf dot set text welcome to Java point. That is what is the action that is going to take place. Once you click the button here, it should display welcome to Java point. Then f dot you are adding the button to the frame and the text field to the frame. Then you are setting the frame size to 400 comma 400 and we are not using any layout manager and we are setting the frame to be visible. So when you run this program, we'll run this program and see. See here what happens here. When you write anything, welcome. I'm writing welcome here and I'm clicking this. So welcome to Java T point is displayed. This is the action that is going to take place. That is whatever you write in this text field, when you once you click the button, welcome to Java T point will be taken by this text field. Next is the label example. First import java.awt.start, then public class label example extends frame and implements action listener. Action listener is an interface, we need to implement it. Then text field object tf and label object and button b object is created. Then label ex constructor is created. Inside that we are creating the object for text field. We are setting the position for this text field using tf.setBounds of 50, 50, 150, 20. Then we are creating the object for the label and we are setting the position for the label using l.setBounds of 50, 100, 250, 20. Then we are creating an object for the button and setting the position of the button by b.setBounds of 50, 150, 60, 30. Then b dot add action listener of this. When we need to an action has to take place once the button is clicked. And then we are adding the button, we are adding the text field, we are adding the label to the frame. Then set size 400, 400. Set the frame size to 400, width 400, height 400. There is no layout manager here. And frame let the frame be visible by setting the set visible to frame will be visible here. In public void action performed action event. So what is happening here? Always the control starts from the main method. When you say new label ex, then control goes into this constructor. And when action performed of action event, when you click this button, what happens? This host address, you will get the host address using this string IP equal to java.net.inet address.get by name of host.get host address. So once you click the button, you need to get the host address. So we'll run this program and see. So whatever you may write. So what happens here when you say find IP? So it is saying no such host is known. Hello. Okay, it is throwing an exception. So you can write any IP address here. For example, 120, something else. Some IP address if you write and say find IP, no such host is known. If you write the IP, it will find the IP address. Okay, if I say localhost, see it is saying IP of the localhost is 127.0.0.1. So you need to enter the host name here. Next is the panel. What is panel? First you need to import java.awt.start, then public class panel ex, Then constructor for panel is created here. Frame object is created. Then panel object is created. Then we are setting the position for the panel. Panel dot set bounds of 40, 80, 200, 200. Then you are setting the panel background to color dot gray. Then you are creating the object for the button. Then you are setting the position for the button. V1 dot set bounds of 50, 100, 80, 30. You are setting the background color for the button as yellow. You are creating an object for button B2 and setting the position for button B2 and setting the background color for button B2 as green. Then you are adding the button B1 and B2 to the panel and adding the panel to the frame. So first you need to add the button to the panel and panel needs to be added to the frame. Then you set the size of the frame, that is width of 400 and height of 400. Then f dot set layout of null. Here there is no layout manager. There is no layout manager is used here. F dot set visible to, you are letting the frame to be visible. So always control starts from the main method. When you say new panel X, the control enters into this panel X. So now run this program. So this is the frame and this is the panel. This gray color is the panel. This panel is added to the frame. Button B1 is yellow color. Button B2 is green color. But no action is performed here. Next is the checkbox example. First you need to import java.awt.star public class checkbox example. In this first create the object for the frame and the label. Then set the alignment of the label. That is where do you position the label? Label dot center. Align the label dot center. Then label dot set size. What is the size of the label? Width and height is 400 is the width, 100 is the height. Then create an object for checkbox 1 and checkbox dot set bound. Set the position for this checkbox. Then create another checkbox and set the position for this checkbox 2. Then add the checkbox 1 and checkbox 2 to the frame and add the label also to the frame. Then you checkbox 1 dot add item listener of new item listener. Public void item state changed of item event E. Label dot set text C++ checkbox. This E dot get state change. That is what is happening here. First, the control enters into the main program. Once you set new checkbox, the control enters into this constructor. So what is happening here? We'll run this program and see. So when you select the C++, then C++ checkbox is checked. If you select Java, Java checkbox is checked. C++ checkbox is unchecked. Whatever action you are performing, whether checking or unchecking, that particular action is displayed here. That is here checkbox 2, checkbox 1 dot add item listener. Here you are using an item listener. What is the event handling you are using here? Add item listener. That is whatever whatever action you perform, whether check or uncheck, that will be displayed here. This is the program. So I'll stop here. I'll continue in the next class. Thank you. Hello everybody. Today I'm going to continue the AWT abstract window toolkit. Now I'm going to explain about choice class. Now what is a choice class? Choice is a predefined class used to create a drop-down menu, and it can be used for a single selection only. Choice can be used for single selection only. That is, only one option can be selected among multiple options. And next is the list. What is a list? List is a predefined class used to create a list box. And list can be used for selecting multiple options among the given options. And next is the Java AWT menu item and menu. This the object of menu item class. It adds a simple labeled menu item on menu. The items used in menu must belong to the menu item or any of its subclass. And it is also a pull down component which is displayed on the menu bar. And next is the scroll bar. What is a scroll bar? Scroll bar is a predefined class used to scroll the cursor either from left to right or from top to bottom. In general, scroll bar can be used to move the content of the window either horizontally or vertically. And the scroll bar object is equal to new scroll bar of direction. What are the arguments you are having inside the scroll bar? Direction, initial position, thumb width, and minimum B value and maximum B value. The direction represents in which order the cursor is moving in the window, that is either in the horizontal or vertical direction. And initial position represents the starting position of the cursor or thumb in the scroll bar. Thumb width represents the thickness of the thumb which can exist in the scroll bar. And minimum B value represents the starting position of the cursor in the left side in the horizontal scroll bar and starting position of cursor at the top level in the vertical scroll bar. And maximum B value represents ending thumb position in the right side in the horizontal scroll bar and the position of the bottom level in the vertical scroll bar. And next is the and okay, we discussed about this panel. Panel is nothing but simplest container class. It provides space in which application can attach any other component. That is, we can add other components like text boxes, text fields, labels to the panel. It doesn't have a title bar. Now coming to listeners, what are these listeners? Uh, these listeners are available in java.awt.event package. What is this event handling? Event handling is a special mechanism used to provide functionalities to the GUI components. And whenever we want to perform any action using any GUI component, mainly those depend on the predefined classes and predefined interfaces called event class and listener interface. That is, for every component, a separate event class and interface is available. And the object of event class stores the reference and content of the GUI components. Now, what is this listener interface? Listener interface is a predefined interface which mainly contains abstract methods. That is, whenever we want to perform any action using the GUI component, the corresponding logic should be written inside the abstract methods of listeners. So what happens by implementing the corresponding interface, event classes and listeners are given to only active components. And that is all the predefined classes and interfaces are available in the java.awt.event package. Now I'll discuss about some listeners, event listeners. First is the action event, and the interface for this action event is action listener. And what are the methods in this interface? Public void action performed of action event. And this action event is related to the button class only button class. And next is second one is the text event related to text listener interface. And the methods in the interface are text value changed of text event. And this text event is related to only text field and text area classes. And next event is the item event or item related to item listener. And what are the methods in this interface? Item state changed of item event. And this item event is related to radio button checkbox as well as choice. So item events are related to radio buttons, checkboxes and choice. And next is the mouse event and related to mouse listener interface. And what are the methods present in this mouse listener interface? Mouse pressed of mouse event key, mouse released of mouse event key, mouse clicked of mouse event key, mouse entered of mouse event key, and mouse exited of mouse event key. These are all the methods present in this mouse listener interface. And these can be used to perform various activities by using the mouse only. This mouse event is applicable only for the mouse. And next is the key event. Key event is related to key listener interface. And what are the methods present in this key listener interface? Key pressed of key event E, key released of key event E, key typed of key event E. And these can be used to perform various operations by using keyboard only. Key event is applicable only for the keyboard. Next is adjustment event related to adjustment listener, and the methods present in this interface are adjustment value changed of adjustment event, and this adjustment event is related only to scroll bar component. Next is the last one is the window event related to window listener, and the methods present in this window listener interface are window opened of window event, window closing of window event, window closed of window event, window activated of window event, window deactivated of window event, window iconified of window event, and window de-iconified of window event. And where is this window event applicable? These are used whenever we want to perform various operations on Windows only. Okay. So Java mouse listener is notified whenever you change the state of the mouse. It is notified against the mouse event. And where it is yet available, the mouse listener interface is found in java.awt.event package. And next is the key listener interface. That is key listener interface is notified whenever you change the state of the key, and it is notified against the key event. And where is this found? The key listener interface is found in java.awt.event package. So next we'll discuss some examples here. First is the text area. Text area I already discussed in the previous video. First import java.awt.star package and public class text area extends frame class but implements action listener interface. Create two objects for label and text area in one button B. Then inside the text area constructor, create the object for the label and set the position for the label using L1.setBounds, and create the object for label L2 and set the position for label L2 using L2.setBounds. Then create an object for text area and button B and set the position for the button B using B.setBounds. Then B.add action listener of this. Then add all these the label 1, label 2, text area and button to the frame. Set the size of the frame, that is width to 400, height to 450. Then there is no set layout null means there is no layout manager used here. Set visible true means the frame is made visible. Then what is the action performed here? String text is equal to area.getText. First you get the text from the text field and store it in the text variable text, and then string words are equal to text dot split. But therefore L1 dot set text of words is words dot length and characters are text dot length. So in this program you are displaying whatever you enter in the text area. It will count the number of words and characters and display the words and characters. So when you run this program, so this is the text area which you added to the frame here. And whatever you enter in this text area, if you say count words, what is the, if you press this button, if you click this button, what action is performed? Words and characters are counted and displayed. So number of words used are 9, and what are the number of characters? 14. So this is the output. Next is the text field. Now what is text field? First import java.awt.star package. Then public class text field example extends the frame class and implements the action listener interface. Then create the instances for text field tf1, tf2, tf3. Create the instances for button v1 and v2. Then inside the constructor, create the object for the text field and set the position of the text field 1 using tf1.setBounds. Create the object for text field tf2 and set the position of tf2 using tf2.setBounds. Then create the object for tf3 text field and set the position of tf3 text field using tf3.setBounds. So here total 3 text fields you are creating, and the tf3.set editable files, that is only text t1 and text field tf1 and tf2 are editable. That is, we can edit only in the text tf1 and tf2. In tf3 you cannot edit. In tf3 only you can see the result. That is why tf3.set editable is set to false. Then create the object for the button b1 and set the position of button b1 using b1.setBounds. Then create the object for button b2 and set the position of button b2 using b2.setBounds. Then b1.add action listener of this and b2.add action listener of this. Okay, then add all these text fields tf1, tf2, tf3 and buttons v1 and v2 to the frame. Set the size of the frame, that is width to 300 and height to 300. Then set layout null means no layout manager is used here. Set visible to, that is let the frame be visible. Then what is the action performed? Always control starts from the main method. When we say new text field ex, the control enters into this controller. And once you say b1.add action listener of this, the control enters into this action performed. Then here, whatever you enter in the text fields, those are stored into the string s1 and s2. And you are parsing, that is converting the string s1 and s2 to integer, the integer dot parsing. Then what are you doing here? In the result text field 3c is 0 and if e dot get source equal to b1. That is, once you click the button b1, addition should take place. And if you click button v2, subtraction has to take place. And result is stored in tf3. Result is converted back to string and it is stored in tf3. So we see the output of this program. So this is text1, tf1, tf2, and this tf3 is not editable. And this tf1 is 45, tf2 is 65. If you click button b1 is the addition button. If you click the addition button, the output will be 110, which is the addition of 45 and 65. And if you click button b2, which is a subtraction of 45 and 65 is minus 20. So this is the output of this program. Next is the choice. First import java.awt.star public class choice example. First create the object for the frame, then create the object for the label, then set the label alignment, that is label.center, then set the label size. What is the size of the label? Width is 400, height is 100. Then create the object for the button name is show. Then set the position for the button using v.setBounds. Then create an object for choice, c equal to new choice. Then set the position of the choice using c.setBounds. Then you add all these names, all these names to the choice box. That is c.add c, c.add c++, c.add java, c.add php, c.add android. These are the items which are added to the choice box. Then add the choice box to the frame and add the label to the frame and also add the button to the frame. Then set the size of the frame to 400, width and height 400. Then f.set layout null means no layout manager is used here. F.set visible true means the frame should be visible here. So always the control starts from the main method. When you say new choice ex, the control enters into this choice ex constructor. And once you say b.add action listener, new action listener, the action will be performed. What is the action here? Um, This the string should be displayed. What is the string which is to be displayed? Programming language selected. That is, whichever language you select from this choice box, that will be printed here. So when you run this output, so this is the choice box. So what is a choice box? Choice box is only one option you can select. Only one option you can select. If I select Java and click the button show, then this should be displayed. Program, whichever language you select, that language should be displayed here. So this is the output of this program. Next is list example. First import java.awt.star, then public class list example. First create an object for the frame and create the object for the label. Then set the alignment for the label as label.center. Then set the size of the label to 500 width and 100 height. Then create an object for the button B and set the position for the button using b.setBounds. Then create an object for the list and then set the position for the list L1 using L1.setBounds. Then add these items to the list. What are the items added to the list L1? L1.add C, L1.add C++, L1.add Java, L1.add PHP. Then again take one more list L2 equal to new list. That is create one more object for the list L2. Then set the position of the list L2 to set using L2.setBounds. Then add these items to the list L2. L2.add turbo C++, L2.add spring, L2.add hibernate, L2.add codeignite. Then add all these list L1, L2 label and button to the frame. Then set the size of the frame to 450 width and 450 height. Set layout f dot set layout null means no layout manager is used here. Then f dot set visible true means let the frame be visible. So always the control starts from the main method. Once you say new list x, the control enters into this constructor. And once the button is clicked, this action is performed. But once you say b dot add action listener of new action listener, the control goes into this method. Public void action performed, and this following string is displayed here. That is, whatever you select from the list boxes, that will be printed as the output. Run this program. So this is list L1, this is list L2. So in the list box, multiple options can be selected. That is, using control key, you can select multiple options. Multiple options means here Java. Here I am selecting Spring and say show. If I click the button show, then programming language selected are Java, Framework and Spring. Then next is the mouse listener. What is a mouse listener? Here also import java.awt.star. Then public class mouse listener extends the frame class and implements mouse listener interface. First create an instance for the label. Then inside the mouse listener constructor, add mouse listener of this. First always the control starts from the main method. Once you say new mouse listener, the control enters into the mouse listener constructor. Then here add mouse listener of this. Once you say add mouse listener of this, then the control enters into first it will create a new label object for the new label, set the position of the label using L.setBounds, then add the label to the frame, set the size of the frame to width 300, height 300, set layout null, no layout manager is used here and frame is visible by set visible true. Then once whatever action we perform, the particular action will be the particular event, whatever event takes place here, the particular action is performed. If you click the mouse, the control enters into this public void mouse clicked. Then mouse clicked will be displayed. If you enter the mouse, then public void mouse entered will execute. Then L dot mouse set text mouse entered will be displayed. If you exit the mouse, then L dot set text mouse exited will be displayed. If you press the mouse, then l.setText mouse pressed will be displayed. If you release the mouse, then l.setText mouse released will be displayed. So run this program and see. So now what happens? Once I enter the mouse, mouse is entered. And once I exited the mouse, it is saying mouse exited. And once I click the mouse, mouse is clicked. And once I press the mouse, mouse is pressed. And once I release the mouse, mouse is released. So this is the output of the program. Next is the key listener. Now what is key listener? First import java.awt.star, then public class key listener extends the frame class and implements the key listener. Then first create an instance for the label and instance for the text area. First always the program control starts from the main method. Once you say new key listener, the control enters into this key listener constructor and it will create an object for the label and set the position of the label by using l.setPoints and create an object for text area and set the position for the text area using area.setPoints. Then once this text area, if you say area.add key listener of this, uh, then the following events will be performed. That is, if you press the key, then l.setText key pressed will be displayed. And if you release the key, l.setText key released will be displayed. And if you type the key, l.setText key type will be displayed. So these all events are performed only for the keyboard. These are the keyboard actions. So once you run this program, so once I press the key typed, and once I release the key released. If I press the key pressed. Okay, this is the output of the program. So I'll continue in the next class. Thank you. Hello everybody, today I'm going to discuss about swings. Java Swing is part of Java Foundation classes, that is JFC, that is used to create Windows-based applications. If you consider the difference between AWT and Swing, AWT is an abstract window toolkit used for GUI-based applications, that is graphical user interface applications, and Swings is used to create Windows-based applications. And Swings is built on the top of AWT API and entirely written in Java. And unlike AWT, Java Swing provides platform independent and lightweight components. Java Swing is having lightweight components, whereas AWT is having heavyweight components. And Java X dot Swing package provides the classes for Java Swing API, such as what are the classes present in Java X dot Swing package? We have JButton, JTextField, JTextArea, JRadioButton, JCheckbox, JMenu, JColorChooser, etc. These are the classes present in Java X dot Swing package. The first one is the Java JButton. The JButton class is used to create a labeled button which is platform independent, and the application result in some action when the button is clicked. What happens when the button is clicked? Some action will take place and it inherits the abstract button class. And next is the Java JLabel. The object of JLabel class is a component for placing the text in a container. Label is nothing but you place some text in the container, that is a JLabel, and it is used to display a single line of text, read only text. That is, this text cannot be changed by the user, and the user cannot edit it directly. That is, text can be changed by an application, but the user cannot change it directly. So this JLabel inherits the J component class. And the next one is the Java JTextField. The object of a JTextField class is a text component that allows the editing of only a single line text, and it inherits the JText component class. And the next one is the Java JTextArea. The object of a JTextArea is a multi-line region that displays the text. That is, if you want to write some multiple lines, then you should go for JTextArea. JTextArea allows the editing of multiple line text, and it inherits the JText component class. Next is the Java JCheckbox. The JCheckbox class is used to create a checkbox, and it is used to turn an option on or off or true or false. And clicking on a checkbox changes its state from on or off or from off to on. And JCheckbox inherits JToggle button class. And next is the Java JRadio button. The JRadio button class is used to create a radio button. So where is the radio button used? It is widely used in exam systems or quiz. And radio button is used to choose only one option from multiple options. And how to use this J radio button? J radio button should be added in the button group before, to select only one radio button. Next is the Java J combo box. The object of choice class is used to show pop-up menu of choices. That is, J combo box is used to show the menu of choices, and the choice selected by the user is shown on the top of the menu. And this J combo box inherits the J component class. Now we'll see some of the examples of this Sphinx examples. First is the JText field. Now what is a JText field? First you need to input java x.swing.star. Then public class JText field example implements action listener interface. Then first create the instances of JText field TF1, TF2 and TF3. You need to create 3 instances for the JText field and 2 instances for the J button B1 and B2. Then first always the control starts from the main method. Once control enters into main method, when it says new J text field example, control enters into this constructor. And first the J frame object is created, then set the J text field object is created, then set the position of the J text field TF1 using TF1.setBounds. Then TF2 text field object is created, then set the position of the text field TF2 using TF2.setBounds. Then TF3 text field object is created, then set the position of the text field TF3 using TF3.setBounds. Then TF3.setCreditable false. That is, the only application can change, whereas user cannot change it directly. Then B1 button B1 equal to new J button. Create the object for the button B1 and set the position of the button B1 using B1.setBounds, and create an object for button B2, and the name of the button B2 is minus, name of the button B1 is plus, and set the position of the button B2 using B2.setBounds. Then B1 dot, once you say B1 dot add action listener of this, the control enters into this action performed of action event. Then whatever text you entered into text field TF1 and TF2, that is stored in the string S1 and S2, then the string is converted to integer by using integer.parseInt. Then once you click the button B1, then addition takes place and the result is stored in the text field C3, text field TF3. And if you click the second button, then subtraction will take place and the result is stored. So when you run this program, so you enter some input here. And if you press the plus button, you get the result of addition of 56 and 78, and the result is displayed in text field TF3. And if you click the second button, that is minus button, the subtraction of 56 and 78 is performed, result is stored in TF3. This is the output of this program. Next is the JTextArea. So first import java x.spring.star public class jTextArea example implements action listener. First you create the instance. First always the control enters into the control starts from the main method. Once you say new jText field jTextArea ex, then control enters into this constructor. And first the object for the JFrame is created, then label object for label 1 is created, and set the position of label L1 using L1.setBounds, and object for label L2 is created, set the position of L2 using L2.setBounds, and next object for jTextArea is created and set the position of the jTextArea using area.setBounds. Then the object for the button B is created and the name of the button is countwords. Then position of the button is set using b.setBounds. Then once you say b dot, these items are all added to the frame, that is L1, L2 area, text area and button B are added to the frame, and size of the frame is set to 450 width and 450 height. Here no layout manager is used. Why? Because f.set layout is null, and f.set visible true means the frame will be visible. And once you say a b dot add action listener of this, the control enters into this action performed of action event, and whatever text you enter into the text area is stored in this string text, and the words are split using this statement, and the word dot length is stored in the label L1, and the characters, that is text dot length, are characters which are stored in the label L2. So when you run this program, so this is the text area. So if you enter some words here, enter some, if I say count words, then words are 5 and characters are 34. This is the output of the program. Next is the J panel. First you create the object for import java.awt.star, then public class jpanel.ex. First the control starts from the main method. When you say new jpanel.ex, control enters into this constructor jpanel.ex. First the object for the jframe is created and the name of the frame is panel example. Next object of the jpanel is created. Then the position of the panel is set using panel.setBounds. Then the background color of the panel is set to color.gray. Then button J button B1 object is created and position of J button B1 is set using B1.setBounds. And background color of the button is color.yellow. And button J button B2 object is created. Then set the position of J button B2 using B2.setBounds. Background color of the button B2 is color.green. Then this button B1 and B2 and panel are added to the panel, and panel is added in turn added to the frame. So when you run this program, so this is the panel, and once you press button B1, no action is performed here because this is static. So this is the output of the program. And next is JFrame EX. So public class JFrame EX. First, you need to import java.awt.flow layout. Here we are using a layout manager called flow layout. Then once always the control starts from the main method, so the first object for the JFrame is created, and the name of the frame is JFrame example. Then the object for the JPanel is created. Then you set the layout of the panel. You set the layout of the panel to new flow layout. Then the object for the J label is created and the name of the label is JFrame by example. Next the object for J button is created. Then set the text for the button as button, and you add the label into the panel and button into the panel, and you in turn add the panel to the frame. Then set the size of the frame to 200 width and 300 height. And set the frame default close operation to jframe.exit on close, and set frame.set visible true means the frame will be visible. By default, frame is not visible, so we should set the frame to be visible by saying frame dot set visible to true. When you run this program, so this is the frame. Inside the frame, you added a panel, and inside to the panel, you added a button. So when you click the button, no action is performed. Why? Because this is static. Here, event handling doesn't take place here. Next is the JLabel.ex. Here also first import java x.swing.start and public class JLabel.ex extends the frame class and implements action listener interface. Then first create instances for JTextFile, TF, label L, JLabel.L and JButtonB. First always the control enter starts from the main method. When you say new JLabel.ex, the control enters into this constructor. And first the object for the JText field is created, then set the position of the JText field using tf.setBounds. Then create the object for the JLabel. The position of the JLabel is created using l.setBounds. And create an object for JButtonB and set the position of the button JButtonB using b.setBounds. Then when you say add all these items, that is add the button, text field and label to the frame. And when you say b dot add action listener of this, the control enters into this action performed of action event. And whatever text you enter into the text field, that is stored in this host. And here you will get the inet address dot get by name of host dot get host address. The host address will be displayed. So if you run this program, whatever host name you enter, that particular host address is displayed. For example, if I enter localhost in this text field and click the button find IP, then the IP of the localhost is this one. IP address is this one for localhost 127.0.0.1. This is the output. Next is the J checkbox. First, you need to import java x.swing.start. Then public class J checkbox example. Always the control starts from the main method. When you say new J checkbox ex, then first the control enters into this J checkbox constructor. First the object for the JFrame is created and the name of the JFrame is checkbox example. Then the object of the JLabel is created. Then align the label to set horizontal alignment. Align the JLabel to center using set horizontal alignment. Then you set the size of the label to 400 width and 100 height. Then create an object for J checkbox. In the checkbox, add the item into the checkbox C++. Then set the position of the checkbox one to using checkbox one dot set bounds. Then create an object for J checkbox 2, checkbox 2 and add the item as Java. Then set the position of checkbox 2 using checkbox 2 dot set bounds. Then add these items components, that is checkbox 1, checkbox 2 and label to the frame. And once you say checkbox 1 dot add item listener of new item listener, then the control enters into this item state changed, and whatever action you perform, that particular action is displayed in the label, in this label. That is whether you check the checkbox or uncheck the checkbox, that particular action is displayed in this label. So if I run this program, so whether if I check this checkbox, then C++ checkbox checked is displayed. Whether if I check this checkbox or not check the checkbox, the following action will be displayed here. This is the output of the program. Next is the J combo box. First you need to import java x.swing.start and public class J combo box example. Always the control starts from the main method. Once you say new J combo box x, the control enters into this constructor. And first the object for the JFrame is created and the name of the JFrame is combo box example. When the object for the J label is created, then you set the alignment of the J label to the center using set horizontal alignment. Then set the size of the J label to 400 width and 100 height. Then create an object for J button and the name of the J button is shown. Set the position of the J button B to B dot set bounds. Then you take one array of languages, string languages equal to C, C++, C Sharp, Java and PHP. Then you create an object for J combo box and you pass this array into the combo box. Then you set the position of the combo box using cd.setBounds. Then add this combo box label button to the frame and set layout f.set layout null means no layout manager is used here. F.set size, that is set the frame size to 350 width and 350 height. And once you say b.add action listener of new action listener, control enters into this action performed, and whichever checkbox means combo box is a choice of it gives choices and you can select any one choice. That is the following program, whichever choice you select, that will be displayed on the label. On the label, that particular output is displayed on the label. So when you run this program, see combo box only one option you can select. You cannot select multiple options. So when you show when you click the show button, the programming language selected is C++ is displayed on the label. This is the label. So this is the output of the program. So now I'll conclude here. I'll continue in the next class. Thank you. Hello everybody. Today I'm going to continue the swing concept. Today I'm going to discuss about Java JList. The object of JList class represents a list of text items. That is, JList is nothing but a list of items, and the list of items can be set up so that the user can choose either single item or multiple items. The user can choose either one item or multiple items, and JList inherits the JComponent class. Next one is the Java JMenuBar, JMenu, and JMenu item. The JMenuBar class is used to display menu bar on the window or a frame. That is, JMenuBar is nothing but you can see a menu bar on the window or frame, and it may have several menus also. And the object of JMenu class is a pull-down menu component which is displayed from the menu bar. It inherits the JMenu item class. And the object of JMenu item class is nothing but it adds a simple labeled menu item. And the items used in the menu must belong to the JMenu item or any of its subclass. And next one is the Java J dialog. The Java J dialog box is nothing but it is a window-like thing which has a title and a border, and it is used to take some form of input from the user. Okay, J dialog is nothing but it is a window-like thing which has a title and a border and a title, and it takes input from the user. It inherits the dialog class. And unlike JFrame, whereas JFrame is having maximize and minimize buttons, but JDialog doesn't have the maximize and minimize buttons. Next is the JPanel. JPanel is a simplest container class. It provides space. JPanel contains the space where the components can be added. That is, components can be attached to the JPanel. It is similar to a container, and it inherits the JComponent class. JPanel doesn't have the title bar. Next is the Java JFrame. The Java x.swing.jframe class is a type of container which inherits the java.awt.frame class. And similar to the frame, which is having labels, buttons, text fields, the Java JFrame is having J labels, J buttons, J text fields as the components. So now we'll see some of the examples for this. First is the Java radio. We'll see what is a radio button. import Java. First you need to import Java x dot swing dot start. Then public class JRadio X extends the JFrame class and implements the action listener interface. First, always the control starts from the main method. Inside the main method, once you say new JRadio X, then the control enters into this constructor JRadio X. And first, the object for the JRadio button RB1 is created, and the name of that JRadio button is mail. And the position of the JRadio button is set using RB1.setBounds. Next, the JRadio button RB2 object is created, and the name of the JRadio button RB2 is female. And the position of RB2 is set using RB2.setBounds. Then once a button group, see always for a radio button, only one option has to be selected. In order to select only one option, you need to add that radio button to the button group. So compulsorily an object of button group must be created. So button group BG equal to new button group object is created. Then first add the radio buttons to the button group. Then create an object for the button B, and the name of the J button is click. Set the position of the button using B dot set bounds. And once first add these radio buttons and buttons to the frame. Then when you say B dot add action listener of this, the control enters into this action performed of action event. If radio button 1 is selected, then show this dialog box that you are male. If radio button 2 is selected, then show this J option pane dot show message dialog that you are female. So when you run this program, we'll see the output. So what is the output here? See, if you select male and click the button, then this is the dialog box. This dialog box doesn't have a maximize and minimize buttons, only close button is there. So your male is displayed here. And if you select female, either you can select only one option, either male or female. And if you select female and click this button, then your female dialog box will be displayed. So this is the output of the program. And next is the JMenu example. First you need to import Java x.swing.star, then public class JMenuAX. First you need to create the instances for JMenu, menu, comma, submenu, and JMenu item, items I1, I2, I3, I4 and I5. Always the control starts from the main method. Once you say new JMenuEX, the control enters into this JMenuEX. And first the object for the JFrame is created, and the name of the JFrame is menu and menu item example. The next item, object for J menu bar is created. Then menu equal to new J menu of menu. Then object for menu is also created, and the name of the menu is menu. And the object for submenu is also created, and name of the submenu is submenu. Then object for I1, I2 menu items are created, and the names for these menu items are item 1, item 2, item 3, item 4 and item 5. First add all these items to the menu. Item 1, item 2, item 3 to the menu, and item 4 and item 5 to the submenu. Then add the submenu to the menu again. Then add menu to the menu bar. Add the menu bar to the frame. See here, first add the items I1, I2 and I3 to the menu, I4 and I5 to the submenu, add the submenu to the menu, add the menu to the menu bar, and add the menu bar to the JFrame. Then when you run this program, what is the output you get here? So this is the menu. If you click on the menu, you get item 1, 2 and 3, because only item 1, 2 and 3 are added to the menu, and item 4 and 5 are added to the submenu. And the submenu is added to the menu is added to the menu bar, and menu bar is added to the frame. So this is the output of the program. Next is the Java list example. First import Java x.swing.star, then public class JList example. First, always the control starts from the main method. When you say new JList EX, the control enters into this constructor. Then first you need to create the object for the JFrame. Then create the object for the JLabel. Set the position of the label. Set the size of the label with width 500 and height 100. Create an object for JButton and the name of the JButton is show. Set the position of the JButton with b.setBounds. Then default list, create an object for default list model and add elements for this list. Add elements for this list. What are the elements you need to add? C++, Java and PHP. Then create an object for JList and add this default list model into the JList. Then set the position of the list JList using list1.setBounds. Then again take one more default list model L2, add the elements to L2, that is turbo C++, struts, string and YII. Then again create one more object for JList list2, set the position of list2 using list2.setBounds, then add list1 and list2 to the frame, add button and label also to the frame. And once you say b.add action listener of new action listener, control enters into action performed of action event. String data is empty here. First, whatever item you select using list1, that will be displayed, and whichever item you select in the list2, that also will be displayed. So multiple items can be displayed on the output. So list is used to select the multiple items. So here Java, if you select Java here in struts here and say click the show button, then programming language selected is Java and framework selected is struts. This is the output of the program. Next is the J dialog. First you need to import Java x.swing.star, then public class J dialog ex and private static J dialog D. Create an instance for J dialog D. Control starts from the main method. When you say new J dialog ex, control enters into this constructor. First create the object for JFrame, then create the object for J dialog, and the name for the J dialog is dialog example. And set the layout of here a flow layout is used here. Set the layout to the dialog using new flow layout and create an object for JButton B. Name of the button is OK, and when we say b.add action listener, control enters into this public void action performed of action event. Then jdialog.d.set visible false. First, initially the J dialog will be false, it will not be visible. Once you click the button, that is this J label is added. Once you click the button, then so we'll see the output of this program actually. So what is happening here? You added the J label to the dialog. Okay, here d.add of new J label. What is the J label name? Click button to continue. You added this J label to this dialog box and add the button also to the dialog box. And once you click the button, what happens? Dialog box will be displayed. Once you click OK, the dialog box will be set visible to false. Okay, this is the action performed. Once you click OK, the dialog box will be made, it will not be visible because set visible is false. So this is the output of the program. So okay, I will continue in the next class. We'll stop here. Thank you. Hello everybody. Today in this class, I'm going to discuss you about a small project on swings. That is, I completed in the previous classes, or I completed the core Java concepts. So today we'll do a small project. This project is based on swings. That is how to design a calculator. So first there is a package named com.calculator. This Java program is to create a simple calculator. So first you need to import java.awt.event.star. Then class cals extends the JFrame class and implements the action listener interface. First create a frame instance, that is static JFrame F. Then create a text field instance, static JTextField L. Then store the operator and create the operator and operands, that is string S0, S1 and S2. S0, S1 and S2 are the strings. Then this is the default constructor. First always the control starts from the main method. Here the first an object is created for the JFrame and the name of the JFrame is calculator. Then inside the try, this is the UI manager dot set look and feel of UI manager dot get system look and feel class, and this is just to set the look and feel. And after the try block, you create the object of the calculator. That is, when you create the object of the class, the control enters into this default constructor, and here S0 is equal to S1 equal to S2 is empty or null. Then create a text field. That is text field. Create an object for the text field. That is L equal to new J text field of size is 16. Then set the text field to non-editable. That is, the text box should be non-editable. Only application can change, whereas the user cannot edit the or change the text field. That is L dot set editable to false. Then create the number buttons and some operators. What are the buttons? J buttons you are taking here. J button B0, B1, B2, B3, B4 up to B9, and BA is for addition, BS is for subtraction, BD is for division, BM is for multiplication, BE is for equal, and okay, three more buttons like BE, BEQ and BEQ1. First create the number buttons. How do you create the number buttons? Create an object for number buttons. That is B0 equal to create an object for B0 and the name of the button is 0. Create the object for B1. Name of the button is 1. Create the object for B2. Name of the button is 2. Create the object for button B3. J button B3. Name of the button is 3. Create the object for B4 button. Name is 4. Create the object for B5 button. Name is 5. Create the object for B6 button. Name is 6. Create the object for B7 button. Name is 7. Create the object for B8 button. Name is 8. Create the object for B9 button. Name is 9. Then equals button. Create the object for equals button. BEQL equal to new J button of equal to. Name of the button is equal. Then create the operator buttons. What are the operators you are having? That is in a calculator. What are the operations you perform? Addition, subtraction, division, multiplication. And this C is for clear operation. So BA button is created. Create an object for BA button. And the name is plus. Create the object for BS button. Name is minus. Create the object for BD button. Name is division. Create the object for BM button and the name is multiplication. Create the object for equal button. For clear button, that is name is C. Then create a dot button. That is BE equal to new J button of dot. Then create a panel. Create an object for JPanel. Why? Because you need to add all these components to this JPanel. Then add action listeners. Once you say BM dot add action listener of C, uh, first add all the elements to the panel P. That is text field, the buttons, everything you add to the panel P. Then set the background color of the panel to blue. Add the panel to the frame. Set the size of the frame to, that is width to 200 and height to 220. Then when you say B dot add action listener of C, when you say B dot add action listener of C, then the control enters into this action public void action performed of action event field. Then string s equal to e dot get action command. And if what is the condition you are checking here? If value is a number, how do you check the condition? If s dot character rate of 0 is greater than or equal to 0 and s dot character rate of 0 is less than or equal to 9 or s dot character rate of 0 is equal to dot. Then begin. If operand is present, then add the second number. That is, if any operand is present, then add the s to the second number. That is, if s1 is not equal to null, then s2 is assigned to s2 plus s, else s0 is assigned to s0 plus s. Then set the value of the text. After performing the operation, you set the value of the text. That is, whatever the operation you perform, then you set the value of the text box. How do you set the value of the text box? To the text field. L is the text field here. L dot set text of s0 plus s1 plus s2. Else if s dot character head of 0 equal to clear. Then clear one letter. How do you clear one letter? S0 is assigned to S1 is assigned to S2 is assigned to none. Then again set the value of text after clearing. That is L dot set text of S0 plus S1 plus S2. Else if S dot character head of 0 is equal to equal. Then print the result. What is the result here? Double TE. Result is double TE. Then store the value in the list. If S1 dot equals of plus operation, then what is the result? Is stored in TA, that is double dot, you convert to S0 to double parse using parse double and S2 to parse double and add the two things and store it in TA. Else if S1 dot equals minus, convert S0 to double using parse double, S2 to double using parse double and subtract the two things and store in TA. Else if S1 dot equals division, convert S0 to double using parse double and S2 to double using parse table, then perform the division and store the result in TE. Else TE equal to double dot parse table of S0 into double dot parse table of S2. Then again set the value of the text. That is L dot set text of S0 plus S1 plus S2 plus equal to the result TE. Then convert it in result into string. How do you convert the string? Using toString method. That is S0 equal to double dot toString of TE. And set S1 equal to S2 equal to null. Else if you find there was no operand, then what you do? If S1 dot equals null or S2 dot equals null, then S1 is assigned to S. That is, if both the strings are null, then S1 will be equal to S. Else evaluate again, else evaluate and store the result in double T. Again, if it is if there are operands, then perform these operations again. Then convert the result to the string using toString method and store it in S0. Then place the operator, that is S1 assigned to S and make the operand blank, S2 is assigned to null. Then set the value of the text, L dot set text of S0 plus S1 plus S2. So once you run this project, calculator project, we'll see how it works. So this is your calculator, small calculator. And this is the text box where the user cannot edit anything or user cannot make any changes here. And these are the buttons, these are the numbers, and these are the operand. These are the operators, and these are the operands. So first I want to perform some addition operation. Then equal to, the result is in the double. If I want to clear this, press the C button. And if I want to perform any subtraction operation, and the result is 98 minus 45 equal to 53. Again, I want to clear this one. And if I want to perform any multiplication, now I want to perform multiplication of any float of double operation. It is 6.8 into 4.3 equal to 29.24. Then again, I want to clear this result. Now I want to perform the division of 8 divided by 3. This is 2.666. So this is how a calculator works. So this is a small mini project where you can all practice this. You can do on your own. Yeah, you can develop mini projects like this. Okay, I'll stop here. Thank you.